Hello everyone. Hello everyone, so welcome to our second live stream for Data Architect and Data Architecture. I hope that you can hear me and you don't hear the music. Let me check whether it is out. So, can you hear me well? Is everything working? Let me see here. Still can hear the music, but I think there's some delay and it should be not there anymore. Hello everyone, so welcome to the live stream. I hope that you can hear me well. If yes, then say yes. Yeah, I'm really happy that we are live again, as I promised last Tuesday. I thought that we're gonna make part 2, and now we are making part 2, so I hope that you're gonna enjoy this session. I hope that it will not be that long, like last time, 4 hours. And I was really surprised with the reactions on the live stream. I checked, like, it has really around 70,000 views now. So a lot of people did turn later to check the stream, and they enjoyed it. So I'm really happy for that. That this topic is something interesting for you, because I know many of you are data analysts, data engineers, and yeah, I don't know, they are like people that are interested in the data architecture and the data architect role. So now we gonna do part 2, and this time it's gonna be like, let's say, hands-on session. So what we're gonna do, I will open, let's say, Draw.io or some tool in order to show you how I think, how I draw the architecture. So today we're gonna have like practice, or let's say we're gonna draw things. It will not be only theory, but before that, there is only one concept that I would like to explain for you, because now it is getting a lot of attention, which is from Databricks. I don't know whether you heard about it, the LTAP architecture. I think it is going to be relevant for many of you, because I know that many of you are learning Databricks. So I thought maybe I'm going to explain it for you, because it is a little bit confusing and still it is very fresh concept. The audio is low, right? So you cannot hear me well. Can you hear me well, or should I increase the audio? Let me check if I can increase something. This is important that you hear me well, otherwise it makes no sense, right? So let me check. Yeah, I think I should increase it a little bit. How about now? Is it better? I think it should be better now. You should be hearing me better. I posted now. So is it now better? You can hear me good? All right. So yeah, as I said, today it's going to be LTAP concept a little bit quickly so that you understand it. And after that, we're gonna go and draw an architecture, and I'm gonna give you my mindset on how I draw it, okay? So now, let's start, but first I'm gonna share my screen and maybe check whether you guys can see it. Oh, I think I have to fix something. Give me a second. It is not sharing the right screen, so that's why I'm gonna switch something. So, and then this. Perfect. Now you should see my screen, right? Now I'm gonna hide this. Yeah, you are able to see it. So I'm gonna make myself a little bit smaller here. Maybe like this. Yeah, so it should be good. All right, so now there is a new architecture that is getting in trend, or let's say people are talking about it. It is the LTAP architecture. It sounds a little bit complicated for you, but I'm gonna say it is not that hard. So I'm gonna try to explain it in easy words so that if you see people are discussing about it in online forums or LinkedIn or maybe at work, you understand what people are talking about, because it is getting now a lot of attention. So the LTAP architecture, which might break, let's say, the way how we draw that architecture. So I'm gonna go through this, and then after that, we're gonna draw some architecture using Draw.io. But first, I would like to cover this concept here. So now let's start. I think many of you knows what is actually an OLAP system or OLTP system. I think, by the way, this might be some questions in the interview, so you should know about those concepts. Now, I'm going to try to explain it in simple words. This is something very old. It's not something like new or anything like that. If you build any application, you need maybe it's a website or something. You're gonna need a storage behind it. Now, in the application, gonna be like there's transactions, events, like customers ordering things. If you are doing e-commerce, whatever the business is, you need something called a database, of course, to do transactional work on the database. So far, this is something that the business do, and nothing is crazy. Now, the thing is, so this is just a database, and it could be anything. It could be like an Oracle, Postgres, MySQL, whatever. So now, this is something that we call OLTP. I think I should make the font a little bit bigger. So OLTP. All right. Yes, I can do it like this. I'm checking whether I have an icon for it or not. No, I don't have. So now, an OLTP, it is a transactional system. So OLTP stands for online transactional processing. So it is all about that we store the data very fast inside the database, and usually we store the database, like in rows. So the data going to be stored in rows. Like for example, if you have customers, each row gonna be like one customer, right, or one order, whatever like that. So it's gonna be stored in rows, and the database is going to be designed in a way that can write and read very fast. But what is very important is that writing fast to the database, because here the transaction is going to happen very fast. A new customer going to log in, a new order going to happen. So a lot of things happening on the app. And what is very important is this arrow, writing very fast. So I'm going to maybe here, can I write here? So writing should be very fast. This is the most important thing. That's why they designed the databases to quickly write the data inside rows. So this is what we call a row store. So it is designed like this. Let me get it like this. So nothing so far crazy. All applications that we build gonna be focusing on OLTP systems. This is what we call OLTP. But now over the time, we got the analysts. Let me get this one here. So the analysts wanna go and build some reports. So they are not from, let's say, from the app side. The app side, we have a lot of usual customer from the business. Let me just hide this here. Make this bigger. So now, the normal users of the app is going to be the normal customers of the business, right? They're going to log in, register, and so on. And the setup is totally fine. Now, on the right side, from the company side, we get the data analyst. We get the people that want to analyze the data. They have the big questions. Now, again, those people gonna target the same database. And they will not be writing actually anything here. So what they're gonna do is actually So they need to, let's say, read a lot of data. And for that, they write SQL queries, something like this. Write SQL queries or their Power BI or whatever. Now, reading from those databases is going to be really slow if it is stored like in raw store, because the raw store is going to be only optimized for the transactions, right? So for small databases, for small businesses, this is not a problem at all. But we have noticed that those guys are writing really big SQL queries, and this big SQL query is going to run on the raw store, which makes everything slow. So actually, this is a setup that is not prepared actually for analytics. It is only prepared for how to call it, for transactions. That's why we decided to move the data and build pipelines to new systems, like for example, maybe a data lake or a data warehouse or whatever. So I'm gonna say data lake for now. So we decided to take one copy of the data from the database and put it inside a data lake. So that those people, they will not bother anymore, first of all, the database, right? And they gonna read the data from a data lake, which is something not that bad, because we have here another, let me just find this here, maybe I can find it, Delta. Like for example, we can store the data in something called Delta tables or Delta lake, where the data is actually stored in a different format. So the data going to be stored like in something called column store. Now the column store, it is, I don't know whether you know about databases and how the indexes are stored. So the column store, it is a perfect format in order to do analytical work. So it runs very perfect on those big SQL queries, and you're going to get amazing performance in order to aggregate the data. Like for example, if you are aggregating by the year, by the category, if you're storing the data inside a column store, things going to be, so column store. So things going to be very fast. So that, the reaction from those storage, like a Delta tables or bucket files, it's going to be way faster than the, let's say, the reaction that you get from a normal databases. That's why we said about those systems that focuses on reading for analytics, OLAP, online analytical processing. All right. So again, we have those two arrows. Maybe I'm gonna do it again with different coloring. So you send a request with your query, but what is very important is the reading. So you should read very fast from this. So again, this is actually the basic concept that's between those two words. We need one database that is prepared in order to do transactional work. So the classical databases that you have in Postgres, MySQL, and so on, it is prepared and optimized for fast reading, fast writing, but it is not prepared for big analytical questions. All right. That's why what we do, we take a copy. Maybe I'm going to put here a copy. We take a copy of the data into a new system. It could be data lake, it could be data warehouse, it could be whatever, that is separated first of all from the normal database and store the data in different format, like the column store. And this is gonna react way faster for reading, or let's say for big analytical queries. Now, writing the data, we don't care about it like the transactional systems, because here writing the data, maybe we do it in one patch, So it could take, I don't know, maybe 3 hours, 4 hours. So writing, it is not something that we have a big stress about it. So write means like copying the data from left to right. So for the OLAP, writing, it is not big issue. We can do it once a day, full batch, but reading for us is very important that our analytical questions comes very fast. Now, about the column store, it is not something that you're gonna find only in Databricks, right? Or like say the open Parquet format. You're gonna find actually this type of storage in many tools. Like for example, even if you make a simple Power BI report, if you load the data inside Power BI, actually, my friends, Power BI internally, inside your Power BI file, gonna turn all your data into a column store, all right? So that means many analytical tools that you know and you are already working with, like as well Tableau, everything is stored as, my friends, a column store, because this is the best format for fast reaction. If you run the query on the row store, good luck getting the answer maybe after a few minutes, like half an hour or an hour. But if you store things inside a column store, things gonna be in seconds maybe. Yeah, so that's why many platforms, many tools adopt this format in order to help the analytics to answer fast the analytical questions. Now, I think this is not something new, all right? This is something very old. Like, I don't know, maybe 30 years we know about this. It's not something that is crazy that we need an OLAP. Now, the thing is, comes Databricks and says, you know what? We're gonna, like, you know what? Currently you have like two words, all right? So I'm gonna split it like this. You're gonna have people that's working on the left side building this system, and you're gonna have as well on the right side, completely different word, different people working on those. Now, on the left, as I told you, Postgres maybe I have here, yeah. So on the left, maybe it is on the on-prem, maybe it is a classical old database, but on the right side, things are getting more modern and people are, let's say, getting high-end solutions. So those two words are getting far and separated from each other, and we have always to go and copy the data between those two platforms. So now Databricks said, and they try to do it like step by step, they said, hey, we have now a perfect platform for the OLAP. We have a platform where you can do analytics, you can store the data inside Delta tables and all those stuff. So they won really big on the OLAP. Now what they are trying to go to this world as well. So they are saying now they as well partnered with Postgres, and now they have something called the lake base. So they are doing a lot of work on this direction where they try to convince this world to go to Databricks as well. So with that, they are dominating both of those over the time. They want to have both of the words, okay? The OLTP and the OLAP. Now, they start working on this like, I think a year ago, something like that, where they start like selling the lake base and they start selling this architecture. Hey, come to us, we can do the whole application inside Databricks and all those stuff. But over the time, and month ago, it's something brand new, guys. It's just like, look at this. We are talking about a month ago. So it's very fresh, where they came with a big announcement and they say, you know what? This picture makes no sense at all. We're gonna all transition, let's say, to something called LTAP. So the LTAP, it is Lake, let me see. It is a Lake Transactional Analytical Processing. So it is combining, where is it? So it is combining both of the words. But how are they gonna do this? Well, it is not that crazy. They're gonna still have the Delta files as an open format for the data. let me bring it like this. So one storage for the data, and you're gonna have on top of it, so, and then they try to build both of the words on top of one copy of the data. So they're gonna try to bring maybe maybe bring this one here just to let you know. So they are saying you don't have to copy the data anymore from left to right. It's gonna be only one copy of the data. It's only one data. So you don't have like left and right. You don't have like two databases. You don't have to build a data pipeline. You don't have to do all those stuff. You're gonna have one copy of the data. And this is the most important message from them. Say one copy of the data. Let me check whether you can hear me right. So now, one copy of the data, and you're gonna have the two engines that actually working with this data. The first one is gonna be, they're gonna have like something like this. Transactional engine. This is the lake base. And another one gonna be the analytical engine. Yeah. So they're gonna have like two engines that works on top of the same data. And that means, so that means your application gonna be sending the data and storing the data using the transactional engine, and it's gonna be stored inside one open format, one copy of the data. And the analytical words gonna be used the analytical engine in order to consume the same copy of the data. And they want the whole thing, of course, to be inside an OLTP system. No, let me see. So like this. So the basic idea is to say, we would like you to use the open formats, and we're gonna have both of the engines of it, and depend on the user. If they are normal users, they're gonna, of course, interact with your app. And if you have analytical user, they're gonna be interacting with the analytical apps. All right. Now it's very weird, right? The arrow is not working now. So yeah. So this is their main idea, and they say for this you don't actually need the old world, the OLAP and the OLTP. So it's announced last month, and I have, of course, I'm gonna say maybe this gonna work, but I have some concerns. I'm gonna let you know what I think about it. Now, one more thing that you have to understand that this is this setup to say I'm gonna store the data, the database inside an open format. This is completely different than the normal databases. Maybe you have to understand that databases, it's something very closed. It's very locked. So database. It is one engine. It is like you know. Let me see, a database, bring someone here. So now, as a user of a database, you will not see anything. It is super closed format. That means if you want to access the data, you want, I don't know, to check the files, you will not see anything. It is very locked, and you can use only, for example, the Postgres in order to work with this database. So it is, or MySQL or SQL Server. So it is super locked system. You cannot use the data for any other purposes. Only the database server can work on it. Only this application can work on it. Now, Databricks with this with the lake base is, of course, to say, no, the data, it is not something dedicated only for one database. The data going to be stored inside an open format. We can use it for anything. We can use it for applications. We can use it for analytics, for AI, for any other purposes. That's why they are trying to break this concept of having, let's say, the data is locked behind a vendor, behind one database, and nothing else can access it, and no one can see it. No one can, let's say, directly manipulate it. And they want to go into the direction of the open Delta files or open data format. Of course, Delta files is not the only open format that we have. So I just want to let you know about those new architecture, let's say, concept that's it's been discussed now. And now why I am not sure about this, it is of course a very good idea. I would like, of course, to have all the data company in one place. I don't want, of course, to go and build the pipelines. I don't want to go and write the data from left to right. This is all time consuming. This is all something that is, of course, it's something that is annoying. But so what I'm trying to say is that I believe in this, of course, and I think this is gonna be something very big in the future. But we do OLAP not only for this. We do OLAP for many other reasons as well, my friends, because if you know a data warehouse, let me show you here. Maybe we talked about this before. Now the thing is, OLAP systems, I'm gonna maybe here, do it like this here. The OLAP systems, it is not only like one copy from the OLTP. OLAP systems is as well moving into direction like, let me draw it like this. We use OLAP systems as well in order to integrate the data. So we're gonna get the data from multiple formats. So what I'm trying to say is that we use OLAP as well in order to integrate the data from multiple source systems, not only to have like one copy of the data. This is very simple said. So that's why there will be two use cases for this. Like if you want, as a data analyst, to analyze multiple source systems, those are multiple source systems. You cannot go and jump between, so you cannot go and jump between different OLTP systems or source systems and start building the report. You would like to have one central place in order to consume the data. So that means if your reports are integrating or using the data from multiple source systems, you still need this OLAP. But in many cases, there are operative reports that actually always like one-to-one to one source system. So I call it always operative report or something like that. So if we have a report that actually needs one source system, then I think this new idea, it is a perfect idea. Because I don't need an extra copy. I just go over here and start consuming the data. But now how about those analytical reports needs multiple source system? Because my friends, source system only focus on one topic. They don't care about you as a data analyst that you're gonna get the data from multiple source systems. There's something that is, the application don't care about it. The applications want just one thing, to be fast, to read and to load the data. That's why OLTP systems only focusing on one system, that's it. But we, as we work on the OLAP, we focus on multiple source systems. So how are they gonna solve this? Of course, currently there is no solution for it. They always think we make one report from one source system, So that's why I believe my question, of course, to Databricks is that how are you gonna solve the data integrations? How are you gonna solve those reports, those dashboards that needs, let's say, multiple source systems? So Yeah, so that's why it's something new, I'm gonna say. But usually I think the platforms don't care about, let's say, those integrated, yeah, or like, let's say, complex reports. They care more about, yeah, you have one source system and you're gonna have one reporting system on top of it. But I think, from my point of view, if this happens, then we can move all those use cases that actually needs only one source system, we can all move them to the LTAP system, because it is awesome that you have only one copy of the data. But of course, that who's gonna be responsible, yeah, on shaping this data? This is as well a big question, right? Because you're gonna have like still always two teams. I cannot believe one team gonna deal with all those stuff. So I still think you're gonna need those data engineers and data analysts that they're gonna say, yeah, this format of delta table is not suitable for me. So they start, I don't know, maybe they're gonna start making different copies and things goes in chaos. I still can't imagine it, but I can imagine it for only those annoying reports that only needs one source system. Maybe we split the word, people are analyzing directly in the source systems, which is awesome thing, because as well, I'm just bouncing now ideas because I didn't thought about it so much. That's why I'm talking with you about it. Now, what I'm trying to see is, yes, we're gonna have a struggle with how we're gonna ship the data in this world. We're gonna have a struggle how you're gonna integrate the data between source systems, multiple source systems. How are you gonna make this big dashboard? But what is really awesome in this picture is that, yeah, we have a lot of customers in reporting and analytics. They gonna ask about live data. I don't know whether, like, once you work on companies, one of the best requirements that people are gonna ask you is, you know what, I would like to have a real data. I would like to have live data. So that's why it's gonna be really hard currently, to be honest. It is really hard to make our OLAP system live with the changes that happens from the OLTP, yeah? We try doing, yeah, streaming, the Delta Live and all those techniques, but it is a hard job. But now, if you have all the data here stored in one copy, all those reports, my friends, are live reports. So they gonna do live analytical, yeah, processing, or let's say reports, insights on top of live data, which is, I think, people gonna love it, yeah? So there are, yeah, I'm gonna say there are a lot of benefits if we manage to do this, but it is a big task. I don't see this gonna happen like very soon in the companies. They will start, I believe, yeah, they have first to migrate, yeah, from their old systems to Databricks, and then they have to find a way how those two words gonna be agreeing on stuff. And yeah, this might be very overwhelming. But I don't see this gonna happen in very soon. But if I'm back to work, I might push a little bit more on this at companies. Like if I get hired as a data architect, I'm gonna try to push on this in order to bring all those use cases from OLTP to the live data. But still, I don't see this gonna happen for those big integrated reports. So I just want to let you know about what is happening now. Maybe this is a little bit easier than checking the documents from Databricks and seeing such a pictures. Yeah, good luck understanding those stuff if you are not too deep dive into how this works. But this is the story, yeah? I always try to simplify it for you. We still have the OLTP, we still have OLAP. This is gonna happen for years. Most of the companies are splitted between those two. It's something completely new, but you should know about it now. If you hear what is LTAP, someone say that in LinkedIn or in YouTube or maybe at your company, now you know what they mean. And as well, I'm gonna say those are my open questions about this architecture. I would like subscribe for this. I would say it is a cool idea to do, but yeah, we have to see. We have to try this out, because bringing two teams into one, it's not only technical thing, it is as well the community, it is as well the politics behind teams, how the organization of teams. So it is something not that simple, because the world is now splitted. If you go to organizations, you're going to find a data team, and you're going to find a team that is responsible about the source systems. So now merging everything in one, that means merging organizations, merging teams, new titles, new stuff. So it is a big thing, but I think this is super modern. If I make a new company, I might go directly to such architecture. So you might think, what Baraa is talking about, is it like data engineering topics? No, this is architecture topics. This is discussion in the architecture. If like, if you are joining a new company as a data architect, you might start discussing those stuff. Yeah. So that was a quick, let's say, discussion from my side about the LTAP. Again, it is like transactional analytical processing. So here the T is transaction, the A is analytical, and here you have the T and the A. This means we are combining both together. But now if you are just a junior, if you are just now learning about data, don't worry about it a lot. You will not find this now. If you join company, you will not find this at all. It is something completely new. And the experts still questioning this, whether this can work. I don't think that's going to happen very fast, but I wanted you to know about those principles. So thus we have covered all those three. So I hope you guys did you understand it? Do we have any questions about this before we go to the next topic? Is this clear? So I'm going to say this is about the first topic that I wanted to cover today. Now we're going to go to another topic, which is the core of this video: how we draw a data architecture, how we let's say how we start. Now I have to make sure there's something clear before I start. There is no best practices on how to do it. There is no one, let's say, someone written a book, or in universities, you go to university and they start teaching you, this is how you draw a data architecture. Each expert in the market, they have their own ways on how to draw it. Like there are a lot of consulting companies, there are really many people that are for years at this domain. And if you bring like 10 different architectures, you're going to find that they are drawing things differently. So that means I cannot teach you, or I cannot show you the standard way on how to draw a data architecture, but I'm going to show you my way that I used in companies. All right. So I was, I don't know whether you know about me. I was in IBM, I was in Bosch, I was in Mercedes-Benz, and I tend at the start as a data engineer, I tend to like draw few things, but over the time I got more, let's say, more experience on how to do those stuff. I met a lot of architects in the companies, and I start, let's say, adapting and learning until I got now my format. And this format worked on one of the biggest data platform at Mercedes-Benz. So I'm gonna, of course, I will not show you the architecture of Mercedes-Benz, no way. I'm gonna just show you my style on how I draw architecture that I used in top companies, okay? And they found it one of the best let's say, architectures that we used a lot. And I saw as well many architects, they start adapting my way on how to do it. So again, this is my way, and you're going to find different people with different ways on how to do it. But I'm going to take you in my questions, how I start from the scratch and how I do it step by step. All right. But if you learn how to do this, I'm pretty sure you're going to be one of, let's say, good architects. I'm not going to like brag about it, but it worked for me. And after many years, I found this is the best format to communicate it with multiple people. Now, usually I have multiple, let's say, architectures, depends on the audience. Like in a company where people don't understand, let's say, technicality, or maybe I'm working directly at the business side, and around me the people, the managers, or maybe I'm working directly with the business expert, with the process expert, and no one understands, let's say, technical terms, the IT terms, I would never go and draw something very technical. So I'm going to draw something that is close to the people, all right? But if I'm working in, let's say, the tech center, or let's say a data team, everyone is from technology background, from IT background, they all studied, they all maybe data engineers, and the managers as well, they are tech people. So if I'm working in an environment where I show my work to multiple tech people, then I go into details. So it's always, you have to adapt. You have to see the environment, you have to see the audience, and you have as well to understand the requirements. Only after that, you start drawing. So now I will not go and draw something, let's say, for managers and show you some boxes and say that's it. I will try to draw an architecture that is, let's say, close to a team that everyone can understand it, like they are tech people, okay? I'm working, let's say, in a team with a lot of data engineers. My manager as well understand tech. So that's why I'm gonna be drawing things for tech people. But if I'm at a company, again, with business people, and I am the only one that knows about those stuff, it makes no sense to go into, let's say, very technical terms inside the architecture and confuse everyone, all right? So now, another thing, there is as well not only no standards on how to draw a data architecture, there is as well no standards, let's say, about the tools. You could use anything you want in order to draw your architecture. You could use PowerPoint. You could use, I don't know, Draw.io. You could use any tool that you have, but it should be digital PDF or something at the end, yeah? So it's not only like drawing at your, I don't know, at your notebook. So there is as well no standard tool in order to do it, but I'm gonna say, I've seen that, we have like 2 words on how to do it. If you are explaining an idea, like me now, you can use the Excel draw like I have it now here. But I'm gonna say this kind of tooling, it's only for explanation, all right? It is not something professional. Like if I get hired into a company, I will not go and draw this like this here and say, okay, this is the data architecture and this stays like here. So I'm gonna use more professional tool, like for example, the Draw.io. Draw.io, it is a tool that is, I'm gonna say, free. So you can download it now and use it. And for many companies, I'm gonna say it is getting, I'm not sharing my screen. This is very good. So it's good that I have the Discord. Let's go back. All right. So I was talking about, about the tools. All right. So, okay. So you see my screen, I'm sharing it, everything perfect. So again, about the tools, there is no standards on how to do it. If you are showing those diagrams here in the Excel draw, I'm gonna say it is good between your colleagues and something like bouncing ideas, you are discussing few stuff. But if you are a data architect and it is your main job, in order to make final drawing, for this big system, I'm gonna say you should be using Draw.io. Let me see here, Draw.io. You can get it for free. So it's something that's, you just can download and start using it. Now, so it looks like this. I don't know whether you have done my data warehouse projects. We use it as well. I'm gonna say this is the most professional tool that you could use in companies, and you're gonna sound like, professional architects. And it is, I'm gonna say, my favorite tool currently on how to draw architectures. I'm using it as, I used it a lot in companies, and it was giving perfect results. So I'm gonna say this is the best tool for me, but again, there is no standards on how to do it. Now, in order to draw an architecture, so I should be, like a little bit here. I didn't prepare, to be honest, for this, but I'm gonna go through this like step by step. So usually what we draw, yeah, we draw like boxes, right? So what do we need? We need like boxes. We need, yeah, we write a text inside it. Like for example here, I don't know, yeah, the source layer. So we need boxes, and not only that, we connect boxes with arrows, all right? So maybe this is a data warehouse. I'm just showing you a few things about the element that we use, and we connect boxes like this maybe. And what I like is to have my own icons and glyphs maybe. Those gonna be awesome in order to bring more and to let people more understand about the element. Of course, you can skip those. I'm not saying that you have to use your icons, but you can use your own icons in order to give shapes. Like for example, if you are saying a database, it's gonna be nice if you go and bring a cylinder for it, right? And if you are saying Kafka, maybe you bring the logo of Kafka. If you are saying about, okay, we are speaking about Power BI, you bring the Power BI icon. So it is as well nice in order to add visuals. And I'm gonna say it's not a must, but it is nice. What is very important is how you draw the shapes, how you connect things, how you make things more clear. Now, I'm gonna say this is actually the element that we do, but I'm not gonna like keep speaking about the visuals. It's all about the thinking, how we draw an architecture. Now, there is one very important concept as a data architect, as you are building a system, is that it's called separation of concern. This is something that I always keep in mind if I'm designing any system. Separation of concern, all right? What this means, my friends, and this is something that I saw a lot of, I'm gonna say the reason of why many data warehouses, why many data systems fails, if you don't follow this simple principle. Now, a separation of concerns is like this. If you build any source system or any system, you're gonna have multiple layers, all right? So you're gonna have maybe, I'm just writing, okay? So bronze layer, you're gonna have, I would not give it bronze layer yet. So you're gonna have layer 1, layer 2. Depends on how much layers you are building. You're gonna end up making those layers, all right? And you're gonna be defining what's gonna happen in each layer, right? Now, if you don't define exactly the rules for each layer, let me just make this. So now, if you don't define the rules, this is very important. That the first thing that I actually do if I'm designing anything, if I don't design the rules for each layer, chaos gonna happen. Like for example, I'll just make this shape to say, transformation. So let's give it a red. Let's have here business rules. So give it another shape. And let's have clean up. And what else we can do? Maybe data modeling. So we do a lot of actions with the data, right? As the data flow flies from left to right, we do a lot of things. What else we can do? What else we can do with the data? I'm gonna leave it like this, maybe filtering the data or something like that. So now, what happens is that if you quickly run into building any system, you got a requirement and you start like, building a system with that. So what could happen is that over the time, if you are not organized, you're gonna be doing different stuff in multiple layers. So maybe at the start, you're gonna be doing things cleaner, right? Maybe not do it like this. So maybe at the start you will be clean at your process. So you say, okay, yeah, for some reason you say, yeah, the first is the cleanup, the next one is transformation, the third we do data modeling, and the last one we do maybe business rules, or way around, or whatever, you are doing. Now, if you don't make it clear for the whole team, and you have, let's say, 5 developers and stuff, you are working on the project, and you have to hurry up, you have deadlines, and you start like, okay, let's go and bring one system, let's bring the second system, let's clean up the data. Now, what could happen if you have multiple developers is that one of your developers is going to start transforming the data in the first layer over the time. All right. And another developer gonna go and say, you know what? The data is already in the layer 2. I'm gonna go and apply just few transformation or business rules. And maybe another developer, as he is doing, or she doing the data modeling, he or she gonna go and start cleaning up the data in the last layer. All right. Now, this is something I found in many projects. I end up as well in many projects at Mercedes-Benz doing something called audit, where I audit different architectures and as well different systems, why they are slow and stuff like that. And it's always like this. They don't have, let's say, a clean data architecture. They don't have like clean rules that the whole team gonna commit on. And over the time, chaos is gonna happen because no one is committing into a roadmap, into a design. So they start really doing everything in everywhere. All right. And that's all because we don't have separation of concerns. We don't have a data architecture that explains the contract, the rules, and this gonna, over the time, maybe this system gonna cost millions over the time, and then the patch load at night takes more than 16 hours, and no one knows why. It's all because it's not clean. You don't have clean work. You cannot work like this. It's like building a building, right? A house, an apartment. You cannot just go and start building immediately. You have to commit to rules. Each layer you introduce into the system should be dedicated for one or multiple tasks. So that's why our job as a data architect is to make sure that it is clear about the activities. What are the things that are allowed to be done inside each layer? So for example, we say this is, we make it clear for everyone in the architecture as well. And we say the layer 1 is only for cleanup activities. You are not allowed to do anything else. And we make it clear. We write it down in the architecture even. We say here it is cleanup, nothing else. And we start writing the rules. So same thing for the next layer. We say here only data transformations. It's only here if you are like integrating the data or something like that. The next layer is only you do business rules, nothing else. And the last layer, you do data modeling. With that, my friends, we have clear ruling onto what happens into each layer. And we, as a data architect, we have to explain this, of course, for the team. And the leads of this team should be responsible of that after something like this. So we should be clear about this in the architects. We should be clear as well about the rules. And after we hand this over, we have to make sure that the team understands it, and as well the people that are reviewing the work from the developers, that they follow the rules that we define in the architecture. So this is something that I keep in my mind once I start designing any data architecture. That my layers should be clear about what we are doing. There is no mix of concerns. So this is, my friends, very important concepts to keep into your mind. If you are building any architecture, that you make separations of concerns. So this is the first, let's say, mindset that I have. This is, of course, just an example. I'm not trying to say we're going to do it like this. just trying to explain the concept that you have into your mind. And we're going to follow this into the whole, maybe system. Now, let me just remove those stuff here. Now, usually in the, I'm going to say, in any data architecture, there's for sure two things. Let me just bring here. So what do you have? Oh, I haven't drawn like a few stuff since maybe a year since I left my job. That's why. There is for sure always, my friends, always two layers. We have the source layer and the consume layer. And whatever the project is, you're going to end up always having at least those two. Why I say at least? Because it could be, let me just bring here something like a database, like this. Maybe I'm going to make it like this so it doesn't hurt. So now we have always those two layers and we have always a source system. Usually the source system is going to be a database, okay? Now, the very basic form of a data architecture is actually having this. That I go and access the data from the source system, and actually that's it. I think this is one of the most basic data architecture that you could do. That you and your Power BI, you go and access the database directly. There is nothing stored. And of course, inside the Power BI, you can go and draw a few things. Like for example, in the Power BI, I do, for example, I do Power Query. I do here Power Query in order to clean up the data. So you might draw something inside Power BI and say here, hey, I do data modeling, and then I do DAX, and then comes my report, right? So you can draw something like this. So then I have the report. So I'm gonna say you might draw something like this. Even something very simple like this, it is a data architecture, but it is a very simple one. Now, what I'm going to say, the next step is, of course, so of course, this is the most basic one. Now, the next one that we usually do is we put our system in between the consume and the source layer. So here it could be anything, depends on the project that you do. It could be a data lake, it could be a data warehouse, it could be a data lake house. It could be any system that you are building. So I'm gonna say, if you do it like this, then we're gonna have more things, of course, to it. So we're gonna have to go and build the layers of the data warehouse. So here you have layer 1 and your layers inside the warehouse. And let me just go and move it like this. So now I introduce, let's say in my data architecture, one more layer. So that I have 3 layers: the source, the data warehouse, and the consume. And now inside the data warehouse, I'm going to call it data warehouse for now. Inside the data warehouse, I have 3 layers. Now, what I'm going to say is that you're going to start like naming things. The very famous one that people use is to call stage, core, and mart. I don't know whether you know those naming, but it is a very famous one that we use in the data warehouse. So I'm gonna make it like this. I should have maybe prepared a few things, but I'm gonna draw from the scratch. I promised to do that on live. That's why we are doing things on live. By the way, drawing that architecture might take really a lot of time. So I hope that I will not waste a lot of time for you, but we can do it together. So why we have those 3 layers? Like it is something very, very classical that we do. That stage, it is we take a copy from the data. We take a copy from the data and put it one-to-one into the data warehouse. Now, a data warehouse could be, my friends here. Do we have here any icon? Oh, we have nice icons, wait. So this is data warehouse, and this is those 2. I'm gonna bring them. So data warehouse, nice icon. And I might be making my data warehouse inside an SQL Postgres, okay? So something like that. Now, the stage, it is just one-to-one copy of the data. So actually that's it, nothing crazy, right? So I'm gonna call this as well. One-to-one copy of the data. So this is the first very important rule that I just defined. Okay, one-to-one copy of the data. Now, if I have multiple sources, if I have multiple sources, that means, my friends, we're gonna have here for each source 1 copy of the data. So I'm gonna just give it a name like this, maybe. Source 1, source 2, and 3. We might give it a technical names maybe later. We'll see how things gonna go. So we're gonna have like those sources, and it's gonna be one-to-one copy of the data, nothing else. We don't do anything else. All right. So the core, it is we take those data into the core and we start doing things like, you can define, of course, what do you want to do. Maybe we can go and clean up the data. So we do transformations, we do data transformations. We might do some maybe data integration. Data integration means we start combining the data into multiple sources. Yeah, source 3. So we start maybe, let's say, changing the shape of the data a little bit, but it is not the final form. And in the mart, it is the last layer, right? It is very close to the Power BI. So usually the marts are the delivery that is shaped and tailored for the consumption. This is very important one. So here, maybe we're gonna make star schema of, I don't know, yeah, the customer or the, yeah, maybe the orders and this, oh yeah, let's call it sales or something. So we make, it's always the last layer is the one that is the delivery for the consumption, and we have to tailor it exactly like the shape the consumer likes. So since we have Power BI, of course, the consumption gonna be in a way that is tailored for Power BI. Okay, so that means in our data warehouse, we have here 2 layers that is only for us as, let's say, a temporary, or let's say, yeah, not temporary, let's say it is like layers that we use in order to prepare the data. But the last one is the critical one because it's going to be taking the shape that Power BI likes. So that means we have here 2 phases in order to prepare the data before going to the last phase, to the star schema, for example, here. So that means in the last layer, whatever you call it, mart or gold or whatever, it's going to be business ready, my friends. It's going to be tailored for the consumption, like maybe you're going to say it's always a star schema. Yeah, you start here putting the rules, how things gonna look like, yeah, in the mart. Now, of course, I'm just speaking here about like few things, but there's way more details than that. But I'm just trying to say, that you should know exactly why you are having those layers. And each one have, like, let's say, a task in your system. And you can call it whatever you want. Like, for example, in one project, I called it the access layer. And here, let me think about the name that I used before. I think I always use core, yeah? And here you can find people calling it landing layer, whatever the name, yeah? It's not that, does it matter? What matters is actually the rules and what you are thinking of those layering. Now, this is, my friends, one of the most, I'm gonna say, I'm used too much to the other tool that I forgot the shortcuts for this one here. So this one, I'm just trying here to connect things a little bit. So this one, I'm gonna say, yeah, it's not that beautiful. This one of the classical warehouses that I'm gonna say, yeah, maybe most of data projects now in the business that are doing this. Yeah, especially in Germany, I met a lot of people that are working in data teams. They just like to build data warehouses. And as well, I was analyzing the job market with, let's say what they are requesting about, as a data engineer, a lot of people are requesting data warehouse experts. So actually, this is one of the classical things that you might see. Now you're gonna find in projects, of course, many different designs on how they do the layering, the naming and stuff like that, but this is one of the most simplest one. Now, of course, you can start, for example, using like some coloring. I'm just now talking about the designs. You can start using some colors. I don't know, the access layer, the core, and stuff like that. You can, a little bit doing designing and boxing of the shapes. You can, for example, put everything here inside one box and maybe change. This is just luxury things, okay? I'm not talking about something very important. I lost the color now, the line. Whatever you do in order to make things clear, for people. So maybe you can start doing those shapes like containers, in order to contain your layers. And so just to make things more clear. Now, by looking at this, I'm gonna say, I don't usually go and put like this Power BI. We don't do it like this. We usually name the use cases as well. So actually, I don't put the tools on the picture. I go and name what are the Power BI dashboard, or let's say the big domains that we do in the consumption. What are the big projects that we do? Maybe here the customer, maybe we have a big dashboard called the customer dashboard, that people knows. And here maybe we can go like the sales dashboards. So actually, you have to name like big projects. What are the, how you are using this star schema, So I usually put like Power BI here on top to indicate, okay, we are talking about the tool Power BI, and here we are using the, let's say, the SQL server. So those icons should be, or must be, never ever the main of the architecture. Then again, if you listen to the part one, we never use the vendor icons as the main thing inside our that architecture. Otherwise, you are selling the product and it makes no sense. It doesn't say anything. Look how beautiful it is. Like if you try to explain this, people can understand immediately, my 3 Power BI projects are all consumed by one star schema. that is stored inside the layer called mart. And this comes from another layer called the core and the stages and stuff like that. So with that, you can see we have data flow from the left side to the right side. Okay, we can see, okay, we have one big layer, we have the second big layer, and then we have the third big layer, and everything is moving from left to right. We have like a data lineage, but data lineage usually use this concept, or let's say this term is about to understand exactly one transformation or one column where it comes from. But as well, in the data architecture, we have to show the lineage, how the data flow from left to right. Of course, we are not done yet. This is only the start. Yeah, this is only the basic things that we might do, yeah, in our data architecture. Of course, we can go and do like deeper things. Now, you might find, just to let you know, another style of drawing those data architectures where it is not from left to right, it is from bottom to up. Let me just try to draw it very quickly. I don't know whether I can do it quickly. So, go to back, send back, to back. So the flow gonna start from the bottom. I saw as well many professional consulting companies do this as well. So they start from bottom and they draw the architecture like this. So at below we have the sources, and then they start doing the layering on top. Like for example here, they're gonna say, first thing we do is the stage. And then we have the core. So things goes stacking on top, and then we have the mart. And then from the mart, we get our consumers, yeah? Like for example, here we have dashboards, and maybe we have, I don't know, self-service. This as well, something, works as well. You can draw it like this. There's no, there is no correct or there is no standards on how to do those stuff. So you can start drawing it from, but like it's ugly now, but I think you get the message. Yeah, so you start connecting from bottom to up, but never, guys, never do it from the way around. It's gonna be very ugly. People understand this way better than the way around. So don't start from the top, with the sources, and then you go down back to the dashboard, all right? This, I think, very bad idea to draw like this. So you have two options, actually. Either you draw it like me. I like it from left to right. I don't know, my mind is wired like this. Or you start drawing from bottom to up. Yeah? I will not keep drawing this one here, but I just want to show you one option on how to do it. And don't draw from top to bottom. This is bad practices. All right. So this is my, let's say this is my way on how I draw things from left to right. I have enough space, but I think things get nicer with the shapes. Now, what I'm gonna say, since we are now going through, I think, already 1 hour and a half, I would like to have a break, 5 minutes, around 5 minutes. Stay there, don't leave, because we're gonna go deeper into exactly different source systems, maybe streaming, maybe APIs. We're gonna do some more layering on top of the data warehouse. We're gonna move things to the lake house. So I'm gonna show you a little bit more details on how to draw this. We're gonna have different types of consumers. So far we have only one Power BI, which is very old. So I'm gonna take now 5 minutes break, and I'm gonna rejoin in 5 minutes. Stay there, stay tuned, and we continue later. So talk to you soon. Where is my break? It is here. I think I have some music for you as well. Be right back. All right, so I'm back. I hope that you have your coffee, your stuff for the next session. And I thought maybe before we go next, that I can grab from you a few questions. If you have in the chat, you can ask, or we can go through a few questions from the Discord. There we have like an extra channel that we have made for the live streams, so that I can maybe prepare for you the right answer, let's say, not quickly some gut feelings, yeah? So yeah, if you have questions, make sure to ask in the chat. I can read it now and answer you. Yeah, otherwise I start with the Discord quickly. Let me see, Discord. Are you enjoying the stream, guys? Is it so far good for you? No, I'm not gonna say it looks like the LTAP looks like a fabric architecture. There is some similarity about, of course, using the open file formats. So both of them are using open file formats. But this idea of bringing both the words into one, it is, I'm gonna say, currently Databricks did the first, let's say, announcement about such architecture. So I'm not gonna say it's similar to Fabric, but both of them are using the open format. Even now, Snowflake as well moved slowly as well to the open formats. At the start, they were closed one, you know, because they are Oracle people, but after that, they start using open formats. So what else do we have? Da-da-dum. All right, let's go through the questions then from the Discord. Maybe I'm gonna share again my screen. All right, so there's no music, right? Now, one question from Lias. Dear Baraa, I have seen a few data analyst jobs positions in which they requested Databricks knowledge. Do you think that they were kind of, yeah, overreacting to it or something like that? Let me see. Have you prepared something for you? Now, I'm gonna announce this in the next videos, yeah, about what I'm doing. But one of the things that I'm doing now, I'm building a data machine that collects, I'm gonna say, yeah, a lot of data from the job posting, so that I do for you some kind of analysis like this that I'm showing you. Let me check again whether you can see it. So I'm collecting now massive amount of job descriptions. I'm building these data systems at my side, and then yeah, cleaning up the data, removing the duplicates, some dead jobs and bad, let's say, duplicates and things that makes no sense, unrelevant things. So I'm collecting so much job descriptions. So far in my lakehouse, I have around, I'm gonna say, 25,000 job posting. And after that, I'm doing a lot of analysis on top of it, because I used to give a lot of opinions from my gut feeling, from my experience, from my work. But this is only one guy in one country working on multiple projects in multiple years. But if I got a question like this, or next time I give you a roadmap, I want this to be very precise and based on facts, you know, without data, you are another person with an opinion. So that's why, my friends, I'm analyzing the data. And this is one of the things that's, I'm going to say, one of the results that I have is how often Databricks is mentioned in the job posting for different roles. And you can see for data engineers, I'm going to say 22% of the job posting are saying you should require or you should have Databricks skills. Now, compared to the others, look at this: data scientist, data analyst, AI engineer, it is very few. Like the question came about data analyst, 88 jobs posting was requesting from a data analyst to have skills in Databricks out of 2000 job posting. So the percentage is very, very low. So that's why I would say it is nice to have as a data analyst to learn Databricks. It is not required. It is not something that is massively requested now. Even data engineers, look at this, 22% is requested from data engineers in the job posting. That's why I'm gonna say, if you're a data analyst and you have already mastered SQL, Power BI, you mastered some theory about statistics, you learn how to do data quality checks, maybe learned Python, only after all those stuff, you start learning platforms like Databricks. So if you don't have Databricks skills, I don't think that they're gonna reject you, okay? So no, my answer based on the data, no, for data analyst, it is not required, but it is nice to have. And again, if you want to stand out the crowd, we have a lot of people now going into data analyst role because it is really easy to get into data analysts. You just have to learn SQL, Power BI, and you are good to go. You have to stand out the crowd. And if you want to do that, you could learn Databricks, Snowflake, or dbt. But it is not a big requirement. About the data analyst being replaced by AI, this is a big question. I think from all the roles that we have, data analyst, data engineer, the AI engineer, the data scientist, I think the most riskiest job currently is the data analyst. But I think a data analyst with AI skills, like cloud skills, like you know how to use the AI in order to quickly answer business questions, to find amazing patterns, to utilize AI. If you have Databricks skills, if you have all those add-ons that you have, I don't think it is going to be very easy to replace you, especially if you are at a company and you start building this domain knowledge about the processes, about the data, about those stuff. You're going to be gold for companies. So if you are inside the company, don't focus too much about how I'm going to be the best of Power BI, how I'm going to be the best of SQL, I'm the fastest one to write SQL. No. Be the one that understands the data processes, understand the business, understand the domain. If you do that, then it's not about anymore replacing you by AI. It's about, I don't know, giving you projects, making you busy because it is gold if you know the domains. So get involved in the company as much as you do about their business, more than the tools. But if you didn't enter yet the company, it's going to be hard for you because, people think that it's going to be replaced by AI. But I can tell you, there is a big hype about the AI as well in the market. The thing is, many companies until now, they are building things using Excel, using Power BI, using old data warehouses. Companies are slow. So don't imagine now everyone is working with the AI and everyone is replaced and stuff like that. No, you have a lot of companies until now searching for data analysts, searching for people that can work with their data warehouse, searching for people that can do Excel, even though we have now Power BI, we have Tableau, we have amazing technology, we have Databricks and all those stuff. But companies still use Excel, still use old technologies. So yes, in the internet, in the media, everywhere, you're going to hear about, AI is replacing and all those stuff. But the company is going to be very slow. We still have the chance to enter. You still have, from the 22,000, there's 2,000 now open job about data analyst. So I'll not now bring it to AI topics, but I'm going to say it's going to take a long time until they get replaced, or even data engineers. And I don't think they're going to get replaced. So that's why I'm going to say this is my honest opinion. Now about the DSA and the algorithm for data engineers, I have as well for you some insights. Let me show you. So my friends, only 19 jobs from around 3,000 jobs in data engineering is requesting DSA or anything about algorithms. So no, as a data engineer, don't waste your time learning DSA, all right? Unless you really want to target those big tech companies, yeah, in USA. So in the job, I'm gonna say in the job descriptions, there is no mention at all, yeah, about DSA in the data engineering, and as well, yeah, or whether it's the word algorithms or anything like that. Only very relevant for data scientists. Okay, but for data engineers and data analysts, the percentage is too low. So, and we have a lot of things to learn, yeah. So don't waste your time. As well, I interviewed. Let me show one. Yeah, and as well, I have interviewed, and I got interviewed by many companies. No one asked me about DSA. Yeah. So, but again, this is in Germany. But those 3,000 jobs are collected, that I collected from multiple countries, yeah, not only Germany. So I collected from USA, I think 100 countries, around 100 countries that are got collected. Only 0.7% are asking about DSA. So no, the facts, the data says, don't do that. And then we get a lot of things, a lot of questions about the bachelor degree. Whether data science, data engineer, data analyst, do I need a degree to enter those domains? And again, this time I'm gonna answer from the data. Look at this. So the gray area, it is jobs that's never mentioned that you should have a degree as a data analyst. So 45% of the jobs that I have collected so far says or doesn't mention even, let's say, a degree. For data engineer, it is really crazy. 55%, they are not asking for a degree. And 27% for data scientist. I totally agree that many job posting about data science requesting or requiring or prefer a degree because there is a lot of math in data science. So they expect people to have degree at least to talk about data science, but you can see here, you can totally enter this domain without a degree. All right. And here it is preferred, not even required. Yeah. So, and I can tell you, especially about data analysts, especially this one, I've met a lot of people that actually don't have a degree of anything about computer science or I don't know, math or anything like that. They just come from another domain, but they love this word, the data analyst, and they start learning, yeah, those techniques and SQL, Python, and Power BI, and all those stuff. So this is what the data tells me, and this is as well what I've seen in the market, in the jobs, in the projects. I think, to be honest, guys, in my team, I was, yeah, in many teams that I've seen, I was one of the few that has master degree in data engineering. Maybe it made my life easy to enter jobs, but it was not required at all. So yeah, I spent 2 years doing master degree. It was nice. I'm not gonna regret it, but I would do it differently now after seeing those results. So yes, you can enter the job market. And with that, I answered most of your questions. All right, so that was quickly about the questions, and yeah, we're gonna go back to our architecture. All right, so now let's keep going. Now, so far, I have drawn those stuff, which is very simple things. It was, yeah, let's say a data warehouse, and it was, I'm gonna say, very high level. Now I might take things to the next level a little bit, where we're gonna dig deeper, a little bit more details into each layer a little bit. And we're gonna be building a different system. I'll just make sure that I have enough space. And I'm gonna start with the source systems first. Now, things are not that, not like simple like this, of course, yeah. So we're gonna have many, I'm gonna speak about big scale project, okay? I'm not gonna speak about simple 2 databases and 1 file or something like that. We're gonna start talking about, yeah, maybe some kind of professional databases or systems. Now, first of all, if you start drawing anything about systems, you have to understand many things about the sources. Like even if it is database, just a second, just to make focus. So we have here enough space. All right. Now, so this is the source layer. I'm gonna just color it like this for now. Make it bigger. Now, first things, you're gonna make a box, or let's say a section for each source system. Like for example, here, I usually go and call it a name. It depends on the name. So sometimes we have like, I don't know, yeah, some weird names on companies, but of course, I'm gonna just give you some dummy names of the systems. So for example, you can go and call it ERP, and you're gonna say this is a database. All right. Now, I'm just gonna make it smaller. You can of course go and give it an icon or something to indicate this is a database. You can go and make it smaller like this. I don't know, but this is not the most important thing. So we make for each source system 1 box like this. And then you can give some descriptions about these source systems, but of course, this all depends on your knowledge about this interface, or let's say this database. Now, if we are connecting anything, I'm gonna just bring this here. So we are building now something called the data lakehouse. If I'm gonna go and connect anything into my new system, I have to have some understanding about this source. So I cannot just go and say, oh, all right, we have a database, and as a data architect, I'm gonna say we're gonna go and draw a row like this arrow, and please, and please, data engineers, do this arrow, build it, and this should be exactly like this. No, you should do more than that. You should do more understanding about this. So sadly, I don't have here those nice sketches because we are using now the boring Excel Drawio. So, but we have something here. So the system owner or something. So first thing, I'm gonna go and make an interview with each source system to understand how they offer the data. And this is something very important because without understanding how they offer the data, you cannot connect anything. Now, this is something that you call a contract. So after I interview, so after I interview this source system, this is architect, I go and interview this source system, and we make something called a contract between me and this source system. A contract, it is just, could be anything, it could be, I don't know, written docs or Word or something like that. He prepared an example. Let me just show you what this means, a contract. This could be some kind of contract that we could make. So we're gonna ask, of course, if I interview a system, like who is responsible for the source system. Like I'm gonna go and put some names on the contract so that if something goes wrong, it's all about I'm getting the data from them, and I would like to understand if something goes wrong, who is responsible actually for this source system. So we have to put some names on it. We have as well to understand how we contact them. Do they have like supporting tickets? Do they have like I'm gonna call them or emailing them and stuff like that? And I should understand as well, agree with them how often I'm allowed to go and get their data. Like for example, if I go as a data architect or data engineer, of course, and I say, okay, I'm gonna go and load your data every day, every hour. And if something goes wrong, I'm gonna do a full load from your source system and start like, I don't know, start doing a lot of things. My friends, each time you do anything to a source system, you are a noise. All right? So, Baraa bricks. So each time we do something to this source system, we are doing some noises to the source system. And if they are not prepared, the system owners, they're going to be really not happy with you. So that's why we have to make an agreement. How often I am allowed to load your data into my system? Is it daily basis? Is it, let me just see, right? Can I load it like once a day? This is the maximum I can do. Can I go and do a full load anytime that I want to do full load? Anytime, like if I want to do full load, can I do it every day I want or only on the weekends? So after talking to the source system, we come with an agreement between them and us. And we write down this contract. So if I want to load the data, I can do it at this hour, at this day, when I can do the full load. How is, like for example, if I want to do a full load, should I do it from this source system or maybe from other source system? And as well, we make a contract about how we're going to get the data. This is of course very important. Like there is always two techniques on how to get the data into your warehouse or into your system. So either we have something called a push. Either we have a push. So that means we are waiting from our side in order to get the data. Wait, let me just put a text on top of it. So push. So push means the system owners, they're gonna develop a script or a job, an ETL job or something from their side in order to push the data to us. And let me see here, maybe, yeah. So they gonna be the one that is pushing the data from their database into my system. They never, like for example, they don't allow you to do it on your own. They say, hey, if you want my data, let me know the target and I will be sending the data to you. I'm responsible for this, all right? But I'm gonna say most of the cases, they might allow you to pull the data on your own. A pull means exactly the opposite. Oh, can I switch it somehow? I think I have to switch back to the other tool. It's getting annoying. Yeah, okay, so a pull, it is the way around. I will be responsible of writing the code that's going to go to the source system and grab the data and put it in my target. So again, push, the source system is pushing their data into our system. Pull, it is we are going to access the database. They're going to give us an access and we're going to grab the data into our warehouse. And this is as well very important to draw in the architecture so people knows how things gonna go. Like it's okay to have it like this and then you write here, for example, maybe text on top of it and you say push something like that. They push it to us, or even you can say, okay, this is a pull. But at least I'm just describing the process. So connecting a new source system needs a lot of, let's say, discussions, a lot of understanding how I'm going to get the data from the sources. And then based on the interview, based on the contracts, only then we can draw the architecture. Yeah. Otherwise, you cannot just go and through, let's say, the errors left and right and say, hey, I'm done. This is the architecture and we're gonna do it like this. Of course, I'm speaking about a low level, like very detailed architecture picture. So that means before me drawing any of those pictures, or let's say those architectures, I have to interview and understand those stuff. Now, that means maybe we're gonna have a picture like this. maybe another system, SRM, where they say, no, you are not allowed, my friends, to grab the data on your own. We're gonna put it somewhere. This is something that actually is very interesting, because somewhere, in many cases, introduces a between layer called landing zone. So we are not even inside the warehouse, yeah, the lake house. So the owner might say, you know what, I'm gonna define for you a folder. Do I have a folder? No, I don't have a folder here. Okay. So it's gonna be like a folder, maybe. So landing zone. And I will push my own data into this folder. Now you might ask why they don't push it inside the lakehouse directly. Why should they do this? Push. Well, my friends, because they cannot deal with the modern architecture that you might have. Like, for example, if you are building things inside Databricks, yeah, you are in the cloud, you are modern, things are really nice there. Making a script from the source system to connect to Databricks, to connect it to cloud, this might be very expensive thing that's the source system gonna do. So it happens a lot, of course, in big companies where they're gonna say, you are not allowed to access my database. You are not allowed to pull the data on your own. I'm gonna push the data into like a folder, shared folder or something like that. And there you can grab my data. So they're gonna push the data somewhere outside of your system. And then your job is, my friends, to go and collect it from this landing zone into your lakehouse. All right. This, you should be prepared for it. You might get such as sources, old sources that are not modern. And believe me, most of the companies, they don't have modern databases. So after I interview, this is the whole thing. After you interview and you talk to people, you have to draw it exactly like the contract. And you can start adding stuff, you know, here on the left side. Let me just remove this guy. Oh. You can say here, I don't know, it's only 2 a.m. it's allowed to, yeah. So I start putting few stuff from the contract inside my architecture, right? So I'm gonna say, all right, this source system, they allow only 2 a.m. and here anytime. So I start like adding some tags like this in order to let everyone knows about when I can, maybe this makes no sense. Way around. I can access the data and pull it anytime from this source system, but those guys, they're gonna make the data available in the landing zone around 2 a.m. And of course, from the landing zone, I can go and access it anytime I want, but there will be only one fresh data from this source system. All right. So you see, things are, if you draw architecture like this, it is high level, yeah. People can understand, I have those layers and those stuff, but what this means, yeah. And if you compare it to this, now things are more clear, yeah, for everyone. What else we can do? We can grab maybe, we can discuss one thing, yeah. Maybe this is something that you would like to understand as well. It is not only about the pull and the push, it's about how we are extracting the data. Let me just remove those guys below and let's introduce a new database. So I don't know what they're gonna call them, yeah? ACG. So now what else we can do is to define how we are getting as well the data. Now, here maybe we are pulling the data by accessing the database, and as well like selecting the data that we need from it. Yeah, so or just like a very normal thing, you access the table and you find maybe the latest changes using a timestamp or something like that, and you pull the data. But sometimes you might get an advanced databases that they say, you know what, we're gonna provide you the data using the CDC. CDC means change data capture. That means let me just move this here. All right. So that means we're gonna push the data to you, of course, but we're gonna put it in incremental way. Like CDC change data captures means they have some kind of in the database implementations to capture in the logs what did change to the database, and based on the changes that happens in the database and in the logs, they're gonna push the data in incremental way. Because here in the pool, in the normal way, you can decide whether you're gonna do a full load or incremental load, right? You decide on it to say, you know what, I'm gonna go and grab everything that I find in the database, or I'm gonna go and only specific timestamp. So we are pulling the data as we want. But with this change data capture, things are way more advanced, where it's gonna be like event based. If something changed, we're gonna push this new thing, this new change, this new event that we had inside the database to you. So I've seen like few databases that we're able to do this, which is really amazing thing. And usually this kind of makes your life easier on how to grab the new changes from the source system. So this is as well something that we could ask about, how we're gonna get the data from the sources. Like, should I access the tables and get what I want? Or do you have a CDC implementation? Do you provide, let's say, the new event, the new changes using this technique? And if they have it, then this is awesome, because I don't have to do a lot of things here and I can get always fresh data from the sources. So this is way nicer. I would not go deep dive into this, then we're gonna be talking about data engineering stuff, but I just want to show you that you have to define for each source system what is the ingest method that we are using. Now, what else we could have? We could have not yet streaming. It's gonna be easy. Do I have an API? I don't have the icon of the API. I told you I'm not that good prepared. Now we could have like here an API, maybe API that is pulling, I don't know, the data about the costs or something like that. Now, as well, APIs, it is usually something that hides behind a database. So, like this. Now, let's call it something, I don't know, costs or something. Now, this source system says, yeah, in order to access my data, you go through an API. Now, what you do is actually just then to interact with the API in order to build your load process from it. So this is as well something that you're gonna find a lot in sources that you cannot access their databases like we do in the CDC or in the first database, but we can access it through an API. And this is of course pain, because usually APIs are not designed for batch loading. It is designed for, let's say, transactions and only to get like the information about one customer. But we in the data lake house, we would like to get like all the customers. So this gonna be of course painful in order how to iterate, how to do the paginating and all those stuff. So now, so far, my friends, everything we are doing is kind of batch loading. And as you can see now, from this picture, we have now this layer, the source system. I will just start putting things into frames. That's why. give me a second in order to make things looks a little bit more beautiful. So yeah, pick another color. No, yeah, whatever. So I really wanted to change the color. We were able to do it like here, right? No, it's font layer. It's here. I spend a lot of time drawing on my iPad. I really forget how to do things in Draw.io. But it looks not nice. Yeah, I'll not waste your time. So now we are having the source system, right? Now we have here something that we usually call the ingest layer, but it is not, let's say, part of our source system. Yeah, it's not like in the medallion architecture, the bronze, silver, gold. It is something that depends on the contract, depends on the technology, depends on how we are getting the data. So this is the ingest, and yeah, so it is not another copy of the data, right? It's only maybe here another copy inside the landing zone where you have an extra copy of the data, but usually those are like techniques in order to explain how I actually grab the data from the sources. I'm gonna make it blue, or let's switch colors, like here, blue, like this. Yeah, looks nice. So as you can see, we have introduced one more layer between the sources and the lakehouse. All right. Now, what we can do actually, now since this is all batch, we can go and say, maybe here and add a note or something. Let me think about it. Maybe I'm going to go and do something like this and say, this is all batch loading. Now, I don't know whether this makes sense. Maybe to take this here. Yeah. So we just say here, batch sources. Because so far we have only batch sources. Even an API, it is a batch. I'm loading so much data in one batch. I'm not streaming the data, right? So all those stuff are still batch. Now, I'm gonna say streaming data, it is something that not all companies have it, but they are moving in this direction. Like batch processing, I'm gonna say it's almost in every project you're gonna do batch processing. Most of the sources, they are inside the database and they offer the data. Okay, go get an access to my database, go and grab it, do incremental load, whatever you want. But you're gonna find less source systems that they really have the time in order to make stream processing. Yeah. So stream processing, it's something that's rarely, I'm gonna say, you're gonna find it in, yeah, companies. Only in modern companies, in companies that are really rich, they have a lot of budget, they have a lot of money, and they, like each source system, they have a lot big budgets and big teams, and they hire engineers, they hire advanced people, and they start turning their sources into stream sources. All right. So you might, if you got into some advanced companies, their sources might be providing the data as stream. Now we can go and add here another box. Let me just arrange to back. All right. So we can do here something, I don't know, UII. It's not anymore a database. It is maybe stream in Kafka. I don't know whether you know the concept of Kafka and all those stuff, but again, we don't have only one standard way on how to work with Kafka as well. We have many different ways on how to do it. There are some modern ways on how to consume data from Kafka, but I've seen as well strange things. Now, in Kafka, usually the source system gonna be the producer. If you learn about the terms, you have always those two terms in Kafka. you have a producer and you have a consumer. Producer is the one that is producing the stream, the events, and usually it is the source system is producing. Now, what you could do, you could as well build for your projects, only for you, the consumer of Kafka in order to consume the events. So that's later. Oh, so that's later. It's not the UE. Ta-da. Remove it. So later you use this consumer in order to load the data into your stream. Now there's again there's different designs on how to do this, but I'm gonna say this is one of the designs that we do. We add here a layer in consumer because those producers usually are very, let's say, not friendly yet to consume, and they are made for other technology and other stuff. That's why we make a consumer for the data in order to read the topics from the producer and a little bit I'm not going to say transform it, just to do few preparations to be more friendly for you to consume. But this is not a must. This is totally optional because I'm going to show you, you actually can consume directly from here inside your lakehouse using Databricks. So it's again something that depends on the style, on the producers. It's something that I'm going to say you have to discuss and you have to know how things works. Now, what I usually do is actually, maybe I'm thinking about it, how I've done it before. I usually make another special box for the streaming in the architecture. So we're going to bring it like this and say, this is just to have some kind of separation, yeah? Oops. So we might do things like this in order to have separations. And usually what I do, anything with streaming, I make it red. Oh, not like this. I just wanted the filling to be red because red means I'm fast, right? And blue means I'm slow. So I'm doing here batch. Yeah, it's all about the language, guys, in order to communicate. So even the coloring, it might add something for the understanding of the architecture. So here I'm going to say stream sources, and maybe I'm going to go and color the whole thing. Like this, the batch going to be the slow one. So yeah, now look at this. It's very clear. We are now doing here. I'm going to remove this one here. We have here a batch processing and here stream processing. And of course, we will not put here timing because we are streaming all the time. If a source system did change, I'm going to get immediately the results. So it is a live stream. Now, just to maybe be more accurate about this picture, actually behind Kafka, it's always something like a database. Yeah, maybe a database or a system, but usually we have like databases as well. Yeah, so the modern, I'm gonna say, sources, they usually do it like this. Let me show you in different place. Maybe like this. Now, the modern sources, currently they offer the data using two techniques. Either they give you an access to the API and say, hey, if you want my data, you access it using an API. And this is especially important if you want to access, again, one record, something like to get the metadata about a customer, about details about one order, one customer, and one things. They say, go and access my API. But if they say, if you want my data in a stream way, then they're gonna offer it in, oops. Come here. So, as a Kafka producer or as a stream, let's say, yeah. So currently, this is one of the most modern designs that are happening from the sources. They don't let you access their database. They offer you those two services. And you as a data engineer or as a data architect, you should be prepared for this to understand how I'm going to use Databricks or Fabric or whatever in order to process those two different sources. But if you enter, again, not that modern company, either they're going to give you full access to their database, or they're going to offer it through the CDC, or they're going to say, hey, I'm going to land it into landing zone first and you're going to access it. So I'm going to say with this, yeah, maybe I've covered almost all the different possibilities that might happen to you in the projects. And the more you play with those tags, the more you add those little notations you add into the architecture, you have a language, to communicate. So now if I go to any developer and I show them this picture, they're gonna understand me after I explain it. After like 1-2 minutes, they're gonna understand exactly what I'm talking about, because it is simple to understand. So as you can see, the data architecture, it's not that standard that we follow. It's language. It's a language that I use in order to communicate, in order to protocol. And you have to understand, with this, I can do a lot of things. I can show it to a developer. And if we got audited from auditors in the companies, I can just show them this picture and they can understand the whole source system without them going through thousands of documents or let's say a lot of documents in order to understand the source. They can open, I'm going to share them this, and they can understand whether we are going into the right direction about the security aspects. So if you have like a security officer on the company, or you got audited, and like any people that's gonna ask me things about my system, I can grab this picture and start explaining for them how I build, let's say, the architecture for this source. So this is gonna be, let's say, my tool in order to communicate to anyone about this system that I'm building, whether developers, whether auditors, whether security officers, whatever happens, I can pull this and say, this is how we do it currently. And you have to be careful to not add so much things, otherwise it's going to be confusing. Find the balance between details and high-level architecture. So now with this, I'm going to say we have covered enough about those two. Most of the companies, guys, like, they are databases, files, and that's it, okay? But if you get into modern companies, tech companies, you should be prepared for so much of data streaming and APIs. So now, with that, we are not yet even inside the lake house. So we are still outside, right? But at least we know about our sources. Now, the lake house, I'm going to say, if we are building a data lake house, we have, of course, to follow very standard, let me just call this data lake house. We're going to follow the medallion architecture for sure. I will not go and invent something else. So medallion architecture, I did delete, no, not yet. Medallion architecture, it's not something that's Databricks invented, okay? Medallion architecture, it is based on the classical data warehouses that we do. All right. So that means we have here 3 layers: the stage, the core, and the mart. And the medallion architecture is as well adopting this kind of designs, but they give it another name called bronze, silver, and gold. That's why it is, it is not something that Databricks, I'm gonna say, thought about it so much, or something that is completely new. They just give it a new analogy and a new naming. So we're gonna have, of course, 3 layers. So we're gonna call it bronze, silver, and gold. And of course, since this is medallion architecture, we have to go and give it some coloring that is suitable. So that you can see immediately we are talking about those stuff. Now, what is important here is, of course, maybe to have one box for each layer. Now I think I have added all those arrows to this box. I'm just trying to here see, arrange to back. So now we start with the bronze. And of course, you're gonna here keep connecting things to understand how the data flows from left to right. So the bronze layer is usually 1-to-1. So what's gonna happen, you're gonna make, I don't know, yeah, one box for each source, just to make sure it's clear how many sources we have inside the bronze. So we're gonna say here we have an ECG, SRM, costs, and I don't know what we call UII. So we're gonna put it here. So just make boxes about each source and just put them below each other's nicely, and then we're gonna put them into a box. Now things gonna get ugly since we have many layers. I'm gonna send to back, and as well the whole thing to back. Yeah, maybe I'm gonna leave it like this. Oh, let's leave it like this. And maybe we start connecting those arrows into exactly those boxes, so that it is clear how the data move from the sources, from the different layers into our new box. Now, what you can do is actually as well to make here clear separation between the sources that are streaming and the sources that are actually patch. Okay, and we can as well color the arrows if you want, just to make things more clear. So now it's not that crazy things, just like make boxes about the sources. And then what is more important than that, I always write down the rules, the most important rules that we agree in the project about those layers. So now, for example, we're gonna say, what we said, 1-to-1 copy of the data. I'm just trying to organize it a little bit. 1-to-1 copy of the data. Oh, let me see. Yeah, we're still streaming. That I'm talking to myself. So 1 copy of the data, we're gonna say no data modeling, no transformations, just to make sure everything is clear. Maybe you're gonna say, okay, this is only append. So those are, I'm gonna say the classical rules that we could do in the bronze layer, but we just give it here a place inside our architecture, so that if someone opens, or like a new person join the project, of course, I'm not gonna go and make here like, I don't know, hundreds of rules. We're gonna have an extra document for that. But what we're gonna say, it is the most important rules that you have to follow in that bronze layer. And then actually we go and keep processing, or let's say keep building those layers. So here we're gonna say, okay, for the silver. Now there is like different ways on how to do the silver. There is as well no standards on how to do it. Each project can do their own stuff. Now, I usually do it like this. We're gonna have everything again 1-to-1, like the sources. Let me just bring this back. So now, what is going on here? There is always a big decision about the layers, whether you're gonna break the data model or you're gonna break the source system or not. So what I mean with the break is to say the shape of the data, or organizing the data inside the silver, gonna stay like the source system. We call it source system oriented. And that means I will never, let's say, change the basic structure of the data model. So if I get like from the source system here, 5 tables, they're going to stay on the bronze 5 tables, and they're going to stay on the silver as well 5 tables. So this is a big decision, whether you break this or you start manipulating the shape of the data into a new data model. So I think from my side that in the silver, we should not break the source system model. And that's all because I've tried this before and it was a big issue, because you're going to have a lot of use cases. You're going to have a lot of customers. This always depends, of course, on the consumer, that they would like to still access the data in the shape of the source system, because they are doing AI use cases, because they are doing some data science stuff, and they are used to the data model from the source system. All right. So that's why we usually don't break the data model. We don't break the structure of the bronze and silver. And because you're going to find some projects about this, they're going to say, hey, I'm going to build here maybe data vault. I'm going to build here, even the star schema, I'm going to start involving silver about it. I'm going to change the whole shape, but I think this is too early for this. So what we're going to say, the rule is going to be here, only the basic cleanup. Again, this depends on the project and depends how things goes. But I'm going to say clean up the data, remove the nulls, remove the bad things, maybe as well rename, introduce naming about some columns. Maybe we can do some enhancements. Maybe we're going to bring some new columns joining the tables, but I'm still not breaking the original data model. So if I get a table called customers, I'm going to still have here a table called customers. So I'm not trying to break the data model. So I'm still going to say no data modeling. All right. And here it will not be appends. We can go and agree on the upsert or the insert, so that we just update the records based on to have how I'm gonna call this for you, to have a core table that's inside it. The update and inserts or the changes that we got from the bronze is correctly processed into one table, so it's not an append anymore. Again, this is data engineering techniques, but still it would be nice if you define it as well in the architecture. What are the rules that you're gonna do? So now, by looking to this, you have already the separation of concerns. They might look similar, but actually they are completely using different rules. Now, what could be as well one very important rule that you have to talk about on those layers is about the shape of the format of the data. Now, what I usually do is that I'm going to say, maybe I'm going to mark it like this to say, front, something like this. And as well for gold. If you don't know this logo, this is a Delta Lake format. This is the Delta Lake that we use in Databricks. Or you can add any format that you want. So what we are saying here is that the rule here is that we have to transform the data into the Delta format. Because as you get data from the sources one-to-one, here you might get CSV, you might get JSON, you might get XMLs, you might get, I don't know, text, any type of format. So here I'm going to say any format is accepted, because my job is to grab the data as fast as possible from those sources into the data lakehouse, into Databricks. So I would not put so much stress on those arrows in order to, on the fly, to format the data. You might lose, the thing is, let me just explain for you. As you copy the data from the left to the right, we try to do the minimum of transformations. We try not to add so much tasks in this arrow from left to right, because on the fly, things might go wrong. Like maybe the connection is bad, or maybe you didn't write the transformation correctly. At the start, your pipelines was correct, but after that, you found some edge cases from the sources that you didn't cover inside the pipeline. And then you have to do another full load because your pipeline was bad. So what I'm trying to say is, always we try in the prawns or even in the landing zone is to not touch the data. I just want from you a copy of the data as it is. And as it is big commit, yeah, big thing, because it could be any format, it could be CSV, it could be again, from Kafka, a lot of JSON files or from the APIs. I would not stress myself on those arrows with the data or the file transformation. That's why on the prawns, I'm gonna say I'm gonna accept any format. But in the silver, I would not accept it anymore. So anything I'm copying from in my data architecture from the prawns into the silver, I have to do transformation for the file format. So that means, my friends, inside the silver, if you see CSV, then someone is not following the rules, okay? This is very important. Now, as you can see, sorry for that. Now we come to the gold. Now, as you can see, those two steps, everything so far until the gold, as I told you, it is something that I designed the way I like it, because I am the engineer or the architect, and depends on the volume, on the interfaces with the sources. We might need some layers and stuff like that. And I designed the way that I like. But the gold, it is one of the hardest things that you have to do, because you are not anymore alone in the gold. Because, my friends, we have now the consumers. And this is big responsibility, as I told you. Now we're gonna go and grab, I will not bring Power BI maybe here. Now this is gonna be the last layer. They call it a lot, access layer, the marts, the presentation layer, whatever, the consume layer, whatever you want to call it. Here things gonna be very clear for everyone. So that means why this is very hard one. Again, the bronze, silver, the ingest, I'm just talking with the tech people. I'm just talking to the source system. I'm just talking to the data engineers. I'm drawing this only for them. But now, as we go to the last layer of the data architecture, this is as well something that I have to explain for the consumers, not only for the data engineers. If I get a new consumer that would like to consume my data lakehouse, I'm going to open this architecture and as well explain for them the different possibilities. So that means, if you look to this, where is this guy? I have the guy. Where is the guy? Here. So here. Let me just break those down. This as well. So that means on the bronze layer, oh man, okay. Oh no, come on, move. All right. So that means on the bronze, on the left side of my data architecture, I have always to be in contact with the source owners of those source systems. And I have to be in contact with the data engineers that are building this architecture. But as we go to the right side, I'm going to start talking to a new type of people. They are finally the business. So they are the business, they are the consumers, they are the stakeholders, they are the one that you are building the project for, that's going to consume your data lake. So that means on the right side, it's going to be different type of people that you are talking about, and as well your data engineers, because they have to go and build it. Now, before I start drawing anything, my friends, we have to make another data contract. So maybe I'm going to make it like this. Data contract between sources and my lakehouse or my system, my platform, my platform. All right. You have to make those contracts between you and between them and you, all right? You have to have those contracts. Now, on the right side, you're going to be the one that is providing the data, and you're going to be the one that is providing the data to others. And that's why, oh, wait. We might end up as well making a new type of contracts between you and the consumers. So something like that. And if I grab back, let me see whether I still have it. Yes. It is something that we call the consumer contracts. So again, you have to define who are you, who your team is, like building this, I'm going to say data products, how they're going to contact you if you are offering the data as data products, how often you refresh the lakehouse, how, like whether it is a batch, it is a source. You have to define your maybe metadata about the gold, to give some metadata. You have to ask them, what they are allowed to do with the data. So you're going to make as well another contract so that people that are consuming your data, of course, I'm speaking about your enterprise, like a really big lake house, okay? Because if you are not offering the data as a product, you should not do this. It's fine because it is the consumer going to be your team and you don't have to make the contract. It's only if you offer it for multiple companies. Now, I think we are almost on the second part of our data architecture. I would like to have a break, again, 5 minutes, because here things gonna get interesting to build the gold layer and what are the different consumers that might start consuming your lakehouse. And as well, I would like to go and add a few more things like the metadata, the pipelines, the data governance and stuff like that. So we're gonna finalize the data architecture that I'm building. And I'm really happy, to be honest. I'm really happy about the progress. I didn't expect this. I thought that I'm gonna go through a few stuff and that's it, but we are getting into a clean architecture, let's say an advanced one. So I'm happy that I'm able to give you my thoughts about it. We are not done yet. Stay here. We have to add the gold. Of course, post your questions. I see less questions in the chat. If you have questions, ask me. You don't have to go to the Discord only. Discord is only for preparations. So ask questions. I'm gonna be back in 5 minutes. So little break and I'm gonna be with you again. So where is my screen? It is here. Coffee break. right, we are back. So I hope that you got here a nice break before we continue to the last part. I'm gonna say from the stream. And I know there's like maybe a lot of information that you have to digest. Maybe you are like, at the start of your journey of data. And this is maybe something that is too much, maybe at the start from you, but it is nice to see for you, let's say, how we draw those architectures and how we I think about it, how we build it step by step. Of course, not everyone in the data job that is required to do those kind of jobs, but I'm gonna say it is a really nice habit that you do at the start, where I'm gonna say, as you are building a small source system, or you are building small, maybe you are making Power BI projects, and you are connecting few files, you are having a process at your work, maybe just draft this. It is good for you to understand how the data flow. It is good for you as well to present it to the others. If someone asks you how the project is going, where are we, what are you building, you can show them the process by showing them this architecture. So I'm gonna say it has a lot of benefits. It's not something that only you have to be a data architect in order to draw those stuff. It is a nice habit that you could add to your work, to show that you are organized, that you have, let's say, you are planning, you know what you are doing. So it has a lot of benefits if you start doing basic shapes. Again, you don't have to do it in Draw.io. You don't have to make things sophisticated. You could just grab, I don't know, PowerPoint or any tool that you like to use in order to draw. Even if you draw things at a paper or something like that, but it should be digital in order to share it with others and stuff like that. So I'm gonna say it is a really nice habit that you do, and it might open the door for you, in your career. Now, I'm gonna say in your career, as I told you at this part one, you can become the data architect of the department or in your team, or even over the time as you get older and you know everything about the company, maybe you're gonna be the principal or the enterprise architect of the whole company. So it really opens, if you are if you are enjoying it and you are able to understand the others, you are able to understand the landscape of the company, and you are able to suggest amazing things, nice migrations and nice stuff, you can really reach high things at your career. So I'm gonna say, give it a chance. Even if you are new, draw those stuff, and for any kind of project, whether it's a very simple one, draw. Always make a sketch, always draw it. You can even present it in, I don't know, if you go to an interview, if you have done a project like portfolio project, like the SQL warehouse that I have done with you in the channel, you can go and draw it and maybe print it. You show them, look, I have done this project, and you start explaining during the interview the whole project. So I'm gonna say it has a lot of benefits. It's helped me a lot in my career. I can tell you, I joined as well. This is something maybe, I had a struggle at the start to speak in German at companies, because I was at the early level and I'm still learning, and I joined very early companies in my early years in Germany. So I use this as communication to others. If I have an idea, I sketch, I make, you show as well my courses, I sketch a lot, but this is as well a way to communicate to the others, not something that is only for data architect. Okay, so gain those skills, draw stuff. Even if you are learning, draw, make sketches, make boxes, make arrows, connect things together, and then everything gonna click for you. As well, you use it if you are talking to others. So now what we're gonna do is to keep going in this, I don't know, journey that we have here. I don't have any yet big ideas what we're gonna consume, but we're gonna do it in the fly. How we can do it? Again, post your questions in the chat, and I will be answering them as much as I can. And if you are asking about how does the data field future looks to you, it looks amazing. I'm gonna say it is not something that's gonna disappear. Companies has data, companies still yeah, I'm gonna say struggle with their data. They want to become data-driven companies. They want to become AI-driven companies. They have a lot of dreams, and yeah, the data jobs is one of them. I'm gonna say most interesting jobs that we have now, if you mix it with AI, especially, and yeah, it's a lot of jobs are open for data, and I'm gonna say you can join any domain. You can be in the healthcare, you could be in the manufacturing, you could be in the finance, in the insurance. You can go wherever you want. At the other end, the architecture gonna look similar. And I'm gonna say, if times go back and I want to decide in my career, I'm gonna pick again data. I might go immediately to data engineering because I love data engineering, but I'm gonna say it has great future. So don't be afraid of it. Just mix it with AI, learn AI topics, and you're gonna be fine. All right. So now let's keep going. I hope this makes sense so far here. What I'm thinking is to move myself 1 second, maybe here. Since we can talk about the right side, yeah, I'm gonna put myself here so that I don't cover anything. I have answered already this question. So if you go back to the stream about AI is replacing data analyst, already answered. Now let's go back here. So what do you have? We are still, let's say, not doing anything with the data. We are not offering it. No one is using it. Yeah, right? So no one is using yet our data. Now, before we go to the goal, there is one thing that I would like to let you know, that over the time, we found out sometimes we could skip bronze in some cases. So bronze sometimes becomes optional if you want to do it. If you have a really advanced way on how to stream your data directly to the bronze, to the silver. So in some cases, if you can do it clean, you can actually leave the bronze. Now, I'm not gonna say optional. I'm gonna say only for patch. So we could do this as well, and I think it is not that bad to go through directly from Kafka into the live delta files inside the silver. And you don't have to go through the bronze. So the bronze in some projects can get only focused only on the patch. But if you want to say, no, I would like everything to be, straightforward, we go all the way through the bronze, you can do it. All right. But in some cases, we were able to do this very nicely without issues, where we stream the data directly into the silver. So I just want to give you this possibility that some cases we can skip batch, skip the bronze if you are streaming directly into silver. Now let's go to the gold. So this is the last layer. And now, my friends, we have a big issue with that. We cannot have the rules the way that we want. We have to start now offering the data as products for the others. Now, I'm going to do it in two scenarios, okay? One scenario where I'm going to say we don't have like really separate consumers. We are, I'm going to put it like this. It is the same project. It is the same people. We are building the dashboards, okay? So I'm building this lakehouse for us. So I'm going to be the one that is preparing the data, and as well the one that is I think I still can't put myself here. So I am the one that is preparing the data, and I'm going to be the one, or my team going to be the one that is consuming the data. It's not someone outside of our projects. So what I'm saying here is we could have the consumers inside our lakehouse, or maybe part of our projects, the way that you want. But if you want to have only the layers, 3 layers inside the lakehouse, you can still put it outside. So now, what is the gold? The gold must be shaped so that we consume it. So that means what I'm trying to say here. You cannot just go and say, I'm going to go and make star schema, because everyone is making star schema. I read it in, I don't know, from Baraa live stream. He draw here star schema, and I'm going to be here doing a star schema, or maybe say this is the star schema of the customers. And this comes from the gold here, and from this source system. And we're going to do it like this immediately. You cannot decide on the gold without first analyzing the requirements that you have for the consumers. You have, of course, you should be doing this from the start of the project, but you should know how to shape the data for the consume. So you cannot blindly, like here, decide the way that you want. No, you have first to understand the consume. So the consume could be many different ways. I think I have experienced all different ways of consuming the lakehouse. Maybe some few things. In my previous projects, before I leave, we had 40 consumers, and I had around 40 consumers of Power BI and over 30 consumers AI projects. My friends all are consuming my lakehouse. I was not the one that is building those stuff at the end, because I was focusing on the lakehouse, but I was providing the data into many projects, and I've seen everything. Let's say I went in all those discussions. I know exactly like how things goes into those stuff. So I'm gonna say things can get crazy if you are making, let's say, clean data warehouse or clean data lakehouse, or your data that you are getting are very important for the company, and you have a lot of consumers that are requiring from you the data. And of course, the more and more you get projects that say, I would like to go and consume, the more hard time you're gonna have how you're gonna shape your gold, because you have a lot of people that have different demands on that gold, and this gonna makes your life really a nightmare on how to shape the data. So now I'm gonna go and cluster those into, I'm gonna say, again, I'm giving you here a big project. I'm not giving you here like a simple scenario. So I'm gonna go and say it is the classical Power BI projects. And I'm gonna say it is maybe other lakehouses projects, and a third could be AI projects. Maybe something like this. So we can cluster the consume of lakehouse and big companies into those 3 categories. Now, Power BI projects, I think is clear, right? Someone want to build a report, someone want to build a dashboard, and they come to you and say, I would like to consume the gold from you. Or maybe your team want to build Power BI reports, or Tableau, of course, So I'm gonna say maybe, let's not give it Power BI, let's call it BI projects, okay? So that we stay generic, because you might get one project is doing Power BI and another one is doing, do we have Tableau? Do we have Tableau? Yes, we have. Oh, we have some nice icons that I could use. So you might have both projects that are consuming, So that's why it's better to call it BI projects. Now, why I say other lake houses? Why we have this? if you joined last stream, you can understand me why I'm saying this, because my friends, in modern data architectures, we have if you remember, the data mesh. No. I think something is wrong. Yeah, no, yes, now we are getting it. Oh, wait, it's jumping between. I'm gonna refresh. Sorry for that. Yes, so slowly. One more tick. Nice. So now, why I'm saying other lake houses or other systems, it is because of this picture in companies. If the company starts making domain-driven architecture where they are developing a data mesh where each one of us is building their lake houses, then we're going to offer the data from the gold or even from the silver to another lake house, to another data project. And that depends, of course, on the architecture. So if things get advanced and you have the company that are developing a domain-driven architecture, my friends, one of your customers, that means, is another lakehouse from another domain. All right, that's why we could have this if we are having the data mesh concepts. And of course, the AI project is getting crazy for us. And this is exactly why data engineers are really important now, because the thing is, if you apply, if you go and do AI use cases directly on those sources, it's going to be really nightmare, because again, the AI project, the people that are involved in those activities, they have to understand how to do the ingest, because they have to build their own RAG. So they have again to go to those discussions, how I can get the data from you, how I'm gonna pull it, full, incremental, CDC, landing zone, blah, blah, blah. So that's why if the company, or if we don't have a data architecture like this, and AI projects needs data, they're gonna spend now maybe half a year just designing, again, those stuff. That's why if an AI project in the company sees that, okay, we have data engineers in the company that are preparing, that are cleaning up the data, that are doing stuff, then, my friends, doing AI projects, it's going to be very simple, easy, because everything is prepared. The AI projects that's going to focus only on the use case. They don't have to focus on how I'm going to get the data from the sources. So that means, and as well, the result of the AI going to be way better if things are prepared. So that's why we are getting very important at companies. We as data engineers, I can tell you quickly, I have done the first, maybe at Mercedes-Benz, the first 5 years, just offering the data to another BI project. And I have done as well in many other companies, the same thing. We build warehouses, we build lake houses for BI, business intelligence, for dashboards, for reports, for ad hoc analysis, for data science and all those stuff. But as we enter the AI area, we become very important for the companies. Suddenly, really, my lake houses that I have built, the things that I have built, became the core elements of any AI project at the companies. That's why automatically become the data engineers at companies very important assets, because without having a clean data, garbage in, garbage out. And the AI projects, they have always to start from the scratch by connecting the dirty data, by connecting, the AI systems into things that are very old, that are things that are not prepared. So that's why many companies now understood how important are we for the AI. That's why data experts, like engineers, like architects, are becoming very important for the AI projects, and the companies are hiring them in order to prepare the data for the AI. So if the company wants to become AI-driven company, they need clean data. And yeah, that's what's the point. Go back to the screen. Yeah, so they are the new incomers into our, as a consumer. And yeah, they became part of our consumer card. So now, what is missing is, of course, to add something like this, source consumers. And maybe you're going to start naming your projects. As I told you, maybe you're going to make, do I have here container, nice container? No. Yeah, maybe I'm going to go and get this container here. So maybe I'm going to start splitting the use cases, depends on the type of the project. So here we're going to say maybe Tableau and Power BI, and maybe I'm going to put this back, go to the back, and you're going to be my text. So middle, so this is going to be maybe the sales dashboard projects, PI projects. Yeah, and then we're gonna have another project where maybe, I don't know, give me names. I don't want to use my project names that I know. Maybe maybe the customer behavior dashboard, BI projects, and so on. So it's gonna be group of projects that's, you can put an icon on it or something from those vendors, but it's not that important. That want to consume the data. And here as well, you start doing the same thing. So you're going to start as well clustering your use cases, depends on the data mesh. This giving the data to other lake houses, again, this is something really advanced, only if the company is really big and working as data-driven company. So here you're going to say, okay, let's say lake house, it depends on how they call it. I'm gonna lake house A. Maybe you have two lake houses are connected like this, and you're gonna have here maybe two AI projects, maybe SHAT 2 data per AI project, or maybe Torque to Doc AI projects. Those are very famous AI standards, I'm going to say now, becoming to to consume the data from you. And here I'm going to put those nice icons just to make sure those stuff is clear, what they are using in their projects. So, now we are getting into the layers again. So go back, and maybe on the lake houses, I'm going to go and use another Databricks, something like this. Looks nice now. I like it. So now, of course, we can do some, I don't know what you have done here on the left side. We can go and use those stuff on the left side to say, you are the PI projects or PI projects. You have under here maybe other lake houses, and here AI projects, something like that. So you have to understand who gonna be your consumers. Now I'm making this as one of the one big lake house, and many people are interested with your lake house, but maybe in your projects you're gonna end up having, my friends, only BI, and that's just not bad. I'm not saying that everything gonna be data mesh and stuff like that. It could be your project classical, you are building a lake house or you are building a data platform in order to be consuming it through dashboards. So I'm not saying this is going to be the standards now. I'm just saying that those are the different possibilities. The same thing like from the sources. I'm not saying that every project is going to have this setup. I'm just saying here you might have those possibilities. Now, after you interview each one of those, let me grab, I'm gonna bring this here, architect. You have really to deep dive into those projects and understand why they need the data and in which shape. So you're gonna go through many interviews. You're gonna understand how they, how they work, why they need it, whether it makes sense. Maybe in many cases, I can tell you, I got in total maybe 200 requests in order to consume my data, but only 70 got connected. So you really have to understand why they want to connect your lakehouse, because you might get some customers, you might get some people, they are building, I don't know, application, like, I don't know, web application, and they join and say, hey, you have the data in the lakehouse, you know what, let me just go and consume it like all others. So I would like really to go and consume your gold, you know. Now, as a data architect, you're gonna say, no way, my friends. We are not building here transactional system. Yeah, you go directly to the sources and talk to them, and you will build your web app directly on the source systems. You don't need a lakehouse in order to build your use case. So not every project, and this is of course very important. You know, you have to dig deeper with people and understand why they need the data. Not each project is automatically accepted to get consumed by the lakehouse. Yeah, you might get some use cases that has nothing to do, with the system that you are building. So as a data architect, you have really to go through every single project that is getting connected, and you have to come up with a design of the gold that makes sense to consume. So how I usually do it is that I try to offer, there is like many different ways on how to design this. And there's ways that I hate and there's ways that I like. Now, there is people that says, you know what, I'm gonna tailor for each use case a mart, data mart, or I don't know, bunch of group of tables. So now they go through, like, they do it like this. Let me just, maybe something like this. They go and start collecting data from left and right, from the silver or stuff like this. And then they tailor this for only one use case, for only one project. It doesn't want to enter. This is really not good tool for explanation. So they start tailoring one mart for each customer. All right. So each new customer I get, they start building a new mart. So it looks like this. Now, this is a bad architecture. This is lazy and I hate it. Thing is, imagine now, I have now here, how much? 6 consumers. What's gonna happen if I have 40 consumers? Really, what can happen? So I'm gonna go and through 40 data marts on top of this. By the way, this is very common. This is like many people that really build this because they don't build a data architecture and don't think about it. So they go and start tailoring one mart for each project. And good luck maintaining those marts if you get more than 5, I'm gonna say, projects connecting to you. You cannot, I'm gonna say, this is not something that is smart. You're gonna need a lot of people. You're gonna need a lot of engineers to just maintain this. And imagine the chaos. Like, those people are going to start building reports left and right, and here you do something wrong on those marts, or there is a business logic, or you done the joins badly, or you forgot to do something on the filters. Yeah, so you're going to have here version 1 and version 2, and the numbers at the ends will make no sense. And believe me, they're gonna hate your lake house. They're gonna hate your project. And they're gonna blame you a lot of it, and you're gonna spend a lot of time just fixing issues and stuff like that. I never do this. This is one of the worst things that you could do, is to tailor for each customer, for each report, for each, I don't know, use case, you tailor one table or one data product. Don't do that. Instead, what we're gonna do, we're gonna try to understand exactly this cluster, understand, okay, why they need those reports, and what is the, let's say, I'm gonna say, like, what is the common between those projects? Like, what we're gonna do is we are gonna go and offer maybe one star schema for a domain called maybe sales. And we're gonna cover inside it as well the customers. So for all BI words, I'm gonna build one data model or one product that could be reused by as much as possible from BI. But I'm not saying, here comes the confusion. I'm not saying I'm gonna offer one product for everything, but at least I'm gonna do my best in order to, let's say, consolidate the requirements into one conformed or one core, I don't know, data model that can serve multiple BI projects. But I don't expect this star schema that I built to be suitable for the AI. You got me? So this will never work. Don't dream of this. If you have multiple shapes of consumers, you're gonna be building multiple shapes of, I'm gonna say, of consumers. So here we might go and build maybe big tables. Maybe you're gonna go and offer like 10 core big tables, cleaned and ready. That is not star schema, but it is in format that the AI likes it. So I'm building like data products by a cluster. So here it says data products. And here as well, data products. So look at this. With this, I'm building a product that is of course serving multiple use cases at the same time. And of course, you might find each use cases that's gonna say, you know what, one use case might need other tables or other data or other shape than the other use case. You try to convince them, or you try to shape it in a way that's it is reusable or satisfying multiple projects. If you get like 80%, everyone happy about it, then it is good. This is way better than having one product for one customer, okay? So now, what are the rules of the gold, if you hear me here, is gonna be use case driven. So it is not anymore source system driven, okay? So that means if I make here an arrow, we can make this actually in the data architecture, something like this, where you're gonna say from left to right, everything is source system oriented. That means the shape of the bronze and the silver gonna be designed by the shape of the sources. I'm not yet speaking a lot with the use cases. I'm just focusing on getting the important tables that are required for the customers, but I'm not shaping the data by the use cases. And here it's going to be the way around. So this is awesome to do in the data architecture, by the way. I can as I've done it, many people understood everything. So this is really nice to draw. And yeah, sorry, things are getting out of hand now. So from use cases to the goals, it will not be source system oriented. It's going to be business or use case. Wait, I have here something ugly. Can I move this? I can move it. Nice. So this is going to be, you can call it use case oriented, or you can say business oriented development. All right. So that means the goal is totally depend on the business, on the use cases. So here we have to do data modeling. We cannot have the shape of the source systems. We have to add the business transformations. We have to change the shape of the data, of course, yeah? So you start adding those rules, and as well, maybe add one more rule. No, one-to-one products. That means there is no one product for one customer, of course. And I could go and add one more cool rule to say, I would like to have everything as view. I don't know whether it's possible for some people to do it, but I managed to make my gold completely using views and not tables. So nothing is persisted. It is completely virtual gold, but it is of course expensive. If you have the budget for that, you can go with the views. But I decided on one of my projects to go completely virtual gold access layer, yeah? So that I don't have to deal with the updates, insert, and all those stuff. And I can change the, let's say, I can create new tables quickly and stuff like that. Now, as you see, each layer is getting its own rules. And now, what could happen is that, yeah, I think I was something like this at the end. You can do it like this. So the lake houses, usually they are as well doing, maybe they're gonna need the data for AI and stuff, so they can go and access either the big tables or they can access their star schemas. So I don't think that we have to make extra shape for the other lake houses. My data products, either big flat tables or big flat tables or star schema. So what is missing is, of course, we have to put it into container, send back. Now I need this one here and one back. Nice, 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 nice. I love it. All right, so, oops. Let me just remove the stuff on top. Now, go up, go up, go up. Now, let's see. Yeah. So again, by looking to this, I'm gonna remove this here. With that, my friends, that means you have to always understand the requirements and try to offer data as a product. And of course, this is only if you are working in data mesh concepts. If you don't have all those stuff, then you just need star schemas and the gold, and you offer those star schemas for your colleagues in the projects, right? And avoid the one-to-one thing. Now, I'm gonna say I'm really happy about this. Now, we come to a few rules that you could break, or let's say you could add to your data architecture. Let me think. Now, you might say, one more rule that you have to be very careful is about to define is where people can access your data. So here you have to make a decision as an architect to say, through the projects, it's only the gold layer going to be the access layer. No one is allowed to access those two, all right? So you can make some rules about the access. Yeah? You can see here, no access, or whatever you can write here. And this is only internally for our data engineers, and only here this is allowed to get access for the others. Yeah, if someone comes and say, hey, I would like to get your, I don't know, yeah, tables from the silver. Now, if you are very strict architect, you're gonna say no, we give data only through the gold. All right. Or if you are more flexible and say, hey, I'm gonna go and offer both silver and gold as a product. So that means if really an AI use case needs the raw data from the silver, they are welcomed to go and access it like this. So it is getting ugly a little bit, but you might allow as well to access the data directly from silver. I was not allowing this because it's gonna run into chaos and I lose flexibility. You have to understand, once you allow access to any layer, you lose the flexibility of changing things. So imagine both of the gold and silver are accessible, yeah, from the consumers. That means I have the nightmare of, as a data engineer or data architect, that I cannot change a lot of things here before I talk to the people here, because I'm gonna make contract with people. So my contracting can start from here. So I'm gonna start contracting people from the silver and gold. So it is responsibility. Like, I don't know, yeah, if you are an architect and say, hey, you are allowed to access bronze, silver, gold, and then you go to next project because you don't care, and then data engineers gonna suffer with this. You see, it's small decision that you make in the data architecture might make the life hell for the data engineers. So you have to be really careful with the design. I decided to not allow the silver to get access from people. If you need something from silver, I'm gonna make my best to bring them into the data product, or maybe to make an extra product especially for that. But leave me alone with the silver and the bronze. I need a full hidden flexibility, doing stuff, yeah, on the changes, so that if something happens from the left side, I can adapt fast. And I know that's no one gonna get affected. Changing a gold, it is one of the hardest things you have to do. Each time you introduce one new column that you introduce, you change the data type, I don't know, you rename a column, something gonna break here if you don't communicate it correctly. Yeah, or maybe in the data contract, it's not allowed at all to change it. So that's why, yeah, you have to be very careful with this. Now I'm gonna say I'm really, really happy with this picture. I guide you through my thoughts and my decisions. Now, what we could add on top of this, there's a lot of things that's, I'm gonna say, add-ons. With this, we have the core of the data architecture, okay? If you can't draw those stuff, then you have it. You don't have to add so many other things. But if you want to stay like adding few small things, you could go and say, hey, you know what? Not only the layers we have here below, like for example, we have the metadata layer on top of the data. This is a little bit show off things as we do. So I'm gonna say here metadata layer to know that, hey, my data, my data lakehouse is so modern that I have an extra layer in order to explain the data or have everything protocols. We might have data quality layer. So we start adding those little boxes below the data architecture. You're gonna find it in many people that do this data architecture, maybe the data pipelines. I don't know, yeah. I can keep here adding boxes until this is not anymore nice, yeah. So maybe here, semantic layer. So, but I really don't care about this because they don't really add a lot of things. It is just nice boxing. What is more important is the rules, the flow of the data, the clarity. So you can add those stuff below your warehouse and explain it. that we do not only pipelining and moving data from left to right, but we as well have multiple layers in order to build this lake house. So you can add those stuff, but I really love doing this, the top-down architecture, the bottom-up. And by the way, this is really nice picture in order to, let me just make it bigger because this is a nice product that we have done now. Now, look at this, my friends, look at this. I can take this and explain it for data engineers. I can take this and explain it for my managers if they know tech. I can, if I talk to my customers, I go into a meeting and I show them exactly this picture. And I tell them, hey, look, I have in the gold 2 products. One has a star schema and another one is big flat tables. We usually give the data for AI like this. And if you want to access my data, I can offer you only those 2 products and you can consume it. But sadly, I cannot give you access to other stuff. There are only engineers. And by the way, the gold, it is a I have a new data model. So you will not find the source systems inside my my product. So you could use it in order to talk to your customers about your data. I could use it in order to talk to the source systems about the data, how to connect. And I can show you this picture. Or I can use it in order to explain it for a new data engineer that is joining my team. Hey, look at this. We do the project exactly like this. With that, they can understand immediately during the onboarding process. If I got audited, in big companies, and happens to me twice, it's not nice. But I learned a lot about data security and a lot of bad designs that I have done. So I can show them this and say, hey, look, the data flow like this. We grab the data from the sources, we ingest, we do it in lake houses into those layers. The access is going to happen only in the gold. On the right side, those are the projects. So I'm going to make my life easy during the audit. I'm going to make my life easy as well if I want to get this approved from the security officer of the company. If the company says the project will not start until you draw the data architecture, then I'm going to draw it like this and go to the security officer and say, hey, look at this. This is our plans, and they are going to agree on it or not, or maybe find issues. And I'm going to use as well this as maybe planning tool. I used it a lot as planning. So I say, hey, you know what? The bronze is built, the silver is built, but gold is still under building. So we can show progress of our projects using the data architecture. You can add some comment on top of it. So it is more than just I'm drawing a plan, I'm just communicating with others. And don't draw so much different pictures. This is more than enough in order to communicate for many different people. I had, as I told you, maybe 1 through 5 years that I keep growing over the time. So at the start, we had only BI project. Then after that, we start connecting this. We are adding more data. So it's gonna grow over the time. But if I still look at this, I should not be confusing anyone if I'm explaining it. So my friends, I'm gonna say, we draw the data architecture that I would do now in some big projects in big companies. This is the process that I might do, and depends, of course, on the size, on the sources, on the requirements. The shape gonna be differently, but it's gonna be having the same soul to the others. Take things from left to right, use it in order to explain the plan and stuff like that. We can go, of course, with more details where we can start adding the notebooks, the scripts that is moving the data from left to right, but I would not do that because then it will not be looking clean. So let me check again. So I'm gonna say this could be full detailed architecture that you could use at companies. This as well, it's not a bad, it's a little bit high level, where you have only a data warehouse. And again, it could be your architecture only, I don't know, I still have it now. It could be only like, I don't know, Power BI consuming directly from tables. Now, I could go through this a little bit more and add more items, but I think you got the picture. I just want to have the feeling about, let's say, how we build the data architecture, how I go through my process. And I hope that with that, you combine the first part where we had the theory, we have explained the different concepts, and now I showed you hands-on how I would start and add those stuff. It is a great habit if you add it. Of course, this thing can take me more than maybe 2-3 months until I come up with the final. So it's something that grow as you go through all meetings and you start building it step by step. But it is, I'm gonna say, if you show this habit in your project, in your company, people are gonna love it, and people are gonna start promoting you, and you become very important, let's say the brain of the data projects. I have a lot of stories, of course, to explain for you what we have done and how this went through, but just by sketching few things made me, let's say, one of the famous data guys at Mercedes-Benz and as well at Bosch. So start drawing, don't be afraid. Even if the company has already one old data architecture, draw your own project. Show it, and as well, if you are now data engineer, you are learning data engineering, you are doing portfolio projects, draw this. It's simple. I just spent 2 hours and I come up with this. If you saw those pictures, then you show that you are, let's say, you could be a leader at the project. You could be the brain of it. You give a lot of indicators, and I'm gonna say, this is one of the data roles that I enjoyed a lot doing. But I'm gonna tell you, I was not only a data architect. I was doing, let's say, multiple, as I say, we put multiple hats. So you could be, I was the project lead, leading the project, leading the whole implementations, at the same time the architect. And as well, I was helping other teams in order to organize their work, in order to build for them this architecture. So I was supporting other projects, not only leading my project, as well supporting the other projects in different departments, not only my department, but as well cross departments and stuff like that. But I'm gonna say, it was for me, I think, few years, and I'm gonna be maybe principal architect at the company. But of course, I enjoyed more that I'm doing both architect and the project. So I'm gonna say, don't expect that once you start drawing those stuff, you're gonna be automatically only the one that is drawing. So you might be the data engineer and as well the data architect. You could be the project lead, leading the project, and as well, or the senior data engineer and as well the data architect. You might be the dedicated one. So there is no one let's say, tailored role for this. I'm gonna say I'm totally happy, satisfied about the progress. We done the theory, we done some practice, and so this is the role. I hope that you enjoyed it. That's brought you some, let's say, some perspective on how to add this to your skills, to enhance your skills. I'm not sure whether I'm gonna make a course about this, but we might do that, where I'm gonna go through more into details about the concepts, maybe do different architectures for different scenarios for different companies. We're gonna see about this. If you have questions, you can post now, and I can maybe read from it and answer a few. Otherwise, I really enjoyed this live stream. I don't know, how about you? Did you enjoy it? And I'm gonna say I would not make part 3 of this. I'm gonna make one more part, or not part. I'm gonna make one more live stream, but it will not be next Tuesday. I'm gonna prepare one to be a personal live stream. So it's gonna be something not about the tech. I'm gonna explain my journey. Who is Baraa behind the SQL course that you know and you loved, and this guy in the YouTube, what is his story? So I would like to give my story because I think it was dramatic life that I had, how I transitioned from country to another country, how things went with me. I have lowlights, I have highlights. So I think it's not that standard story that you know, and I might give you maybe live stream about my life. If you are interested, of course. This will not be maybe adding any skills for you, but if you want to hear stories, I think the next stream gonna be about who am I, what are my mindset, how I think, and what was the story that happened in my life. If you are interested, it's gonna be the next one, but I have to prepare it because I think I have so much things that I don't want to forget. All right. Now, I think that's it. One more thing that I would like to celebrate with you guys. This is the first month that I got 2 million views in 1 month. This is the highest record that we have in the channel, and this is all because of you. So I'm gonna say thank you so much for all the love, for all the comments, for all the sharing, the likes. I read all your comments. Like every day before I sleep, I open my mobile and start scrolling into your comments. I really don't use a lot social media. I don't use Instagrams. I don't do this dumb scrolling and stuff like that. I work, I enjoy my life, but if I want to go into social media, I read your comments, and it is lovely. I cannot imagine, I really cannot imagine your support. It is impossible. So I cannot imagine this, but thank you so much for supporting the channel. If you are not yet, do that, subscribe and like. I have a lot of content for you. I really can spend 10 years just making content. I didn't even start. I have so much things about the AI, about the cloud, about the data and cloud and the AI, about the data bricks. I haven't started yet. I have so much data energy for this channel, but only with your support. Don't let me go back to the companies. I like making content. So if you don't support, if you don't show, I don't know. It's still, we have only 30% subscribing to the channel, but I think we can increase that because we have 500,000 regular visitor, 500,000 regular visitor to the channel. So I think if people really subscribe, you can make me at least 3 million subscribers, but I will not now keep talking about this. I'm really happy about this journey that I have. It's not yet 1 year away from Mercedes-Benz, but I'm enjoying it so much. I didn't expect this. It is being an amazing journey, making the content. I'm gonna keep doing this, and you see guys how I'm growing with you through the content. I have my now Harold's doing the editing of the content, and and I have so much new ideas for you. I have so much projects, and very excited. So if you keep supporting and you keep enjoying the content, I will keep doing this. Otherwise, I go back and shut down the camera and start, I don't know, doing data architect for some companies. So now I'm gonna say, stay motivated. Don't read so much about that. There is no jobs and there is no stuff. If you love your job, if you like to be a data engineer, if you like to be a data analyst, for sure you're gonna find a job, all right? But if you are doing it only for the money and you are not skilled, and you don't like programming as a data engineer, you are just doing it for the money, you will not succeed. So you only make it because you love it. The data has so much, I'm gonna say, to offer, and they're gonna stay needing us, especially data engineers. I'm gonna say, keep it up, keep learning, keep pushing, and you can meet any dream that you want, all right? I am just a guy from Syria, and I became one of the, let's say, most of the famous data guy at Mercedes-Benz, leading projects and building all those stuff. You can reach whatever you want. I hope this helps. Thank you so much for watching this live stream. I enjoyed it so much, and I'm gonna see you in the next videos. Ducks gonna be in the next. So stay tuned. There will be so much content. Thank you so much for being here, and I love you all. Bye-bye.